coming to you. And Alashim, hi there! How you all doing? How is life treating you? Hi the bee, hi the generic person, hi the Rolo, hi the autistic panzer, hi! Oh! Hold on. The water clicked. It's time to make myself a cup and then get to work. Okay. I am learning integration. Good for you. Good for you. How is it going, the integration studies? You enjoying it so far? It seems simpler, but I just need the rules to be in my mind. I mean, at the core of the concept, it is really simple. Day 16. Yeah, I know, generic person, I know. I know. But first, things first. I'm rendering, as always. Obviously, I'm rendering the background. I've made an animation because I'm trying to kind of showcase how metallic bonds just increase the amounts of energy levels with the more atoms you add. And let me just tell you, it's going slowly. It's one frame of animation. You can't see it right now because it takes it away. One frame of animation takes a minute. A full-blown minute. And there are 600 frames. That's 10 hours actually. I was already on 200. How many more is left? Oh my goodness, only done 100 frames. Oh, that's brilliant. That's gonna take a bit. Anyway, today I thought we could put some more effort into the video actually, because we might as well, we didn't record last time because my PC was experiencing, let's just call it issues, and a couple of them. But today, hopefully, it will be better. So that's the hope. I need to wake up. I'm falling asleep. I'm falling asleep, I need to wake up. We have a whole video ahead of us. Okay. Yeah. Yes, alright, brilliant. Now I'm ready. Addition to bonds, yep. And we're gonna start by recording. We're gonna start by recording the script that we need for the video. So let's get to it. There are so many animations, alright. Me. Oh, shut up, make it. No, I could hear myself for a second. Absolutely terrible. Last video, I went from basic mathematics through quantum mechanics up to electron orbitals, and as such, I will not be repeating myself. So with electron orbitals is where we'll start. So, 1s orbital looks like this. Now let's say that we take two 1s orbitals and we bring them closer together. Due to the rules I've explained in the last video, when you bring them closer together, these two orbitals become two new orbitals, the bonding sigma and the anti-bonding sigma. As the name would suggest, the bonding sigma helps our molecule bond, whilst the anti-bonding does the exact opposite. And whilst in the last video we've talked about this through a lens of quantum mechanics and wave functions, this time we'll focus on the orbitals and shapes. So, sigma bonds look like this. Anti-bonding sigma looks like this. Now you can see that the bonding brings the atoms together, whilst the anti-bonding pushes them apart. But the bond between two hydrogens I've covered before, so let's focus on some new material. For example, let's read the first chapter. To be fair, it's very short. Maggie, would you consider making 3,7-dimethyl 1,1 allyls and consuming it? I don't know what that is. I just do not know what that is. Okay, that was the first chapter. To be fair, it was a really short one. Second, my memory tells me it was way longer. A bond between two p orbitals, whilst s orbitals are simple spheres, p orbitals are hourglass shaped, so a bond between them will look more like this. And this. And this is a pi bond. So, I feel like the difference between a pi bond and a sigma bond is pretty clear and pretty self-explanatory, but what's important to see is their energy levels. So basically, when we have a sigma bond, the bonding sigma is lower in energy than the s orbitals, whilst the anti-bonding sigma is higher. Now, do keep in mind that less energy means more stable bond, because everything in our universe wants to have as little energy as possible. This means that if we start with one electron on each s orbital, both of them will fall onto the sigma bond, reducing energy, causing it to be a more stable bond. But if we start with two each, two will go to sigma, two of them will go to anti-sigma, and you need more energy, no bond. That's why hydrogen bonds and helium doesn't. Now let's add the p orbitals to the picture like so. There we go. We've got additional 2 orbitals per subshell, which means that we've got 3 orbitals per side. This is what they all look like, and as you can see, p means this kind of hourglass shape. We'll get to it soon. And each of these orbitals is just a different orientation. Now when they bond, they produce 2 pi bonds and a sigma. What is wrong with me? Why am I... Now when they bond, they produce 2 pi bonds and a sigma. I'm gonna lose my mind. Now when they bond, they produce 2 pi bonds and a single sigma bond. And we've already got a couple of things to discuss. First of all, pi bonds have a smaller difference in energy than sigma bonds. This makes them weaker and... Okay, think about it this way. Alright, stop the recording for now to keep our chat. It's a caffeine analog, stronger impact nervous system but lower impact on the heart. Although you really need to get better at your communication skills, because why would you ever start with the IUPAC name over the description of a molecule? My goodness. There is a reason why we have common names. I'm gonna start. Yeah. Okay. Who's testing your knowledge, make it? That's an idiotic way to test someone's knowledge. I can promise you, no one... Well, okay, no, that is not true. There are some people who memorize, like, IUPAC names. But those people are just autistic. And I took a test on stream, I'm not autistic. If you want autism test, just rewind the live streams. It has no common name I'm aware of, besides more fun and some spends. Yeah, but the description of what it does, the name is absolutely irrelevant. I have ADHD, so I was sleepy when I drink it. If you're sleepy when you drink coffee... That's curious. I don't know. I am mostly... I have placeboed myself with coffee taste, so that I just wake up whenever I taste the taste of coffee. I still, to this day, do not know if the coffee I'm drinking has caffeine or doesn't. I don't know. It doesn't say that it has caffeine, it doesn't say that it doesn't have caffeine. But all I know is that the taste definitely works for me as placebo, so I keep drinking it. Me. Imagine that you have a weight on a table. Heck, imagine you have 2 weights on a table, one heavy and one lighter. Here on the side, I'll add these bars to represent potential energy of the weights. They both start at the same point because potential energy is relative, and we have 2 additional states we can reach. First, we can drop the weights, which will reduce the potential energies, and since the more massive weight has... hold on, let me check notes. Actually, wait, for this, it would be really useful to have like a paper sound. Where's my notebook? Has anyone seen my notebook? Just recording. Where's my notebook? My bitch of a husband took it. He was drinking orange. Coffee here tastes like cat piss ammonias. That's what wakes me up. Do you have any cats? Are there any cats around you when you drink coffee? Because that could explain the cat piss mystery. Oh, there it is. Alright, I found it. I found the notebook. Yeah, it's a pretty good paper rustling sound. Let's try again. Imagine that you have a weight on a table. Heck, imagine you have two weights on a table. One heavy, one lighter. Here on the side, I'll add these two bars to represent potential energy of the weights. They both start at the same point, because potential energy is relative, and we have two additional states we can reach. First, we can drop the weights, which will reduce their potential energy. And since the more massive weight has... hold on, let me just... right. More mass... it will drop more in energy. The lighter weight will drop less in energy. Then the next state we need to concern ourselves with is what happens when we bring the weights even higher. Once we do that, the energy of the heavy weights increases even more than the lightweight. Simple as it could be. Now what this effectively means is that if you drop both our weights, then the heavier weight will lose more energy, and therefore it will be even more stable, because you'll need more energy to bring it up. The same way it works for our bonds. The sigma bond is a kind of like our more massive weight. The pi bond is kind of like the lighter, hence why the drop and raise in energy is greater here and smaller here. So this is kind of like our weight hovering in space. This is kind of like the weight on the table, and this is kind of like the weight on the floor. So there, that's how the S bond can be more stable. Now next, how can p orbitals form pi bonds and a sigma bond? Well, the nice thing about this video is that we've done all the heavy quantum lifting in the last one, which means that instead of having to explain it with mathematics, I can just show you that this is our first pi bond, this is the second, and then this is the sigma. It's really simple when you put it that way, isn't it? Alright, let me stop it for now. Okay. Sigma bonds means free connections, right? No, sigma bond just means a connection. I can show them to you if you want. I just happen to have them modeled in Blender. Let me find them. There we go. This right here is what sigma bonds are. So right here you have like the first atom, right here you have the second one, and then this is a sigma bond between them. Whilst p bonds look like this, where right here you have the first atom with, for some reason I can't draw on this. Right here you have the first atom, right here you have the second one. These are the respective p orbitals, and then they form this kind of bond. Isn't sigma the social bond that makes? It's the dreams. I'm having a strong... Okay, where did I even finish off with the recording? I really need to get a move on this video. I mean, look at this, nothing is finished. Okay, there we go. So now, if we go on and display all of the orbitals of nitrogen, once again, with this axis representing energy, in this case, these arrows represent electrons again. Up arrow for electrons with up spin, down arrow for electrons with down spin, it doesn't really matter. The point is, each orbital can hold at most 2 electrons. And if I bring in another nitrogen to the mix, then the bottom s1 orbitals will come together and creating a bonding sigma and anti-bonding sigma. The two s orbitals will come together and create a bonding sigma and an anti-bonding sigma. And then the two p orbitals that are head-on will create bonding sigma and an anti-bonding sigma, whilst the other two create bonding and anti-bonding pi. Now we have all of those orbitals, but not all of them are filled. So in order to figure out which ones get filled, we take our electrons and we start filling them, bottom to top. And there we go. This is the bond structure in nitrogen gas. Now I will zoom in on all of these bonds and slowly go over all of them, because there is a lot of information and I want you to understand it. Okay, so let's go through it once again. These shapes right here are the electrons in the nitrogens on their own, which means that if we have a nitrogen, then it would look like this. Which means that if we have a nitrogen, then it would look like this. Oh my goodness, why am I having such a hard time breathing? Again, this always happens. Alright. First, the nucleus with 7 protons and 7 neutrons. Protons all have positive charge, so they push themselves apart. Neutrons don't have a charge, so using a spillover strong interaction, the nuclear force, they keep the nucleus together. Then this positive charge attracts negative charges. And what has negative charges? Electrons. So it attracts 7 electrons to balance itself out. Then these electrons have different shapes. So first we start with the two 1s orbitals. Then two 2s orbitals. Then 3 2p orbitals. And there, behold, a nitrogen. Now, as we take another nitrogen and bring them both together, the electrons change. And now they look like this. We have 2 electrons on the 1s. Nope, that's not what it says make it. We have 2 electrons on the 1 sigma orbital, 2 on the 1 antibonding sigma, 2 on the 2 bonding sigma, 2 on the 2 antibonding sigma, and then 2 on the sigma bonding from the p orbitals, and finally 4 on the 2 pi bonds, and there, we've run out of electrons. So this is what those orbitals are, these shapes. So why did I show you them from the perspective of energy? Well, it's because if I take the differences in energy between nitrogens on their own and in a bond, then this is what we get. We have to remember to duplicate the nitrogens on their own because that's 2 of them, and then if I just put all of these cylinders together, we get more energy from nitrogens on their own rather than in the bond. Which means that if you want to break the bond, you need to make up the difference in energy. So this is the energy you need to put in order to break the bond. Or in other words, this is how much energy nitrogen emits when it goes from atoms to a molecule. Or conversely, how much energy you need to give it to break the bond between nitrogen atoms and break the bond between nitrogen atoms in nitrogen gas. And so there we go. This is what the bonds look like, this is why they happen, this is why molecules don't randomly break down. And oh my goodness, we just started the video. Geez, how much of a recording do we have? 10 minutes so far. Okay. I would say like solid 30% of it is just broken, so... Oh. Make it, could you stop the Gen Z brain rot? You just said isn't sigma bond the social bond that make it makes? Buddy, who is the brain rot in here? Make it, you need to achieve energy efficient powers into plastic into diesel. That's how we see snow again. I genuinely want to do that, B, actually. I am a hoarder, which is a problem, but at the same time, I do actually stockpile all of my plastic that I have from all the printing, because I do actually want to do pyrolysis on all that plastic at some point. to see if I could. It would be fun. I would be able to turn plastic, useless plastic scrap, into oil or diesel. It would be great, in my personal opinion. Make a pretty fun video. I'm having so much trouble breathing. But it's fine, we are on page... Which page of the script? For some reason on my phone I can't see that. We are in fact on page... 5! Goodness gracious me! Have you heard about the guy who achieved it efficiently then disappeared? Cannon-looking reactor in his backyard. Are you talking about... I'm sorry, hold on. Are you talking about the pyrolysis? What was their name? Hold on. I'm on their Discord server, so let me just check. Nature Job! There we go. Are you talking about Nature Job? Because, like, Nature Job has been doing it. Nature Job. Did Nature Job disappear? What do you mean disappeared? The last video was 2 weeks ago. What do you mean disappeared? Yeah, I remember... Stop watching porn! I don't know what that was about. It was very unfortunate because I remember I joined in right as he got banned. Really bad. I think it was a month or so ago. Google it. I'm not gonna Google it. I'm not gonna Google something that my eyes, like, perceive. Alright. Well, do you mean they went off the internet? Well, they disappeared from the internet for 2 months? Because that's not a lot of time. That's not disappearing. I would call it a solid night of drinking for me. Oh, who pinged me? Who dares? Hi, the Katsi, by the way. Oh, kill.
Yeah.
Yeah, hi.
Hello.
Hold on, I'm only halfway through the video. I'm recording. Oh, my phone is on 6% power. What a brilliant planning on my part. Okay. me.
Okay.
What's up? Just whatever, it's fine. Okay, that's because our orbitals don't need to go in a bond. Fuck, already messed up. Okay, that's because our orbitals don't need to go into a bond to change. They can also hybridize, a topic I've briefly touched upon in the last video, but this time to give you a more concrete understanding of it, imagine a carbon atom. In this carbon atom on the valence shell, which just means the outermost shell, we have 2 electrons on the 2s and 2 electrons on the 2p. Now you might be wondering, which of the 2 orientations of the electrons are on, but... well, they are on all of them, but only on the 2, if that makes sense, which it shouldn't because it doesn't make sense. So basically, let's just say that the universe doesn't exactly know where they are until we do something with them. So with that in mind, let's imagine we bring in our 4 hydrogens to our carbon. It does have 4 free electrons ready to bond, so it should be fine, right? Well, yeah, but if we were to bond them right now, then 2 hydrogens would have to bond with the p orbitals, and the other 2 would have to bond with the s, which means that the first one would have to bond like this, second one like this, and then the other 2, well, they could go wherever they please, so they'd move to the opposite side as far away from the 2 hydrogens and from themselves. Why? Well, it's because electrons all have negative charge and same charges repel, so they all want to stay as far away from each other as possible. So that's why they move to the opposite side, except if that's the case, then which hydrogens would go here and which hydrogens would go there? Well, remember how with the p orbitals, electrons, if they... what's wrong with me? Why can I not breathe? Well, remember how with the p orbitals, if you have 2 electrons out of 3 orbitals, then they won't occupy any specific 2, only they will occupy some 2 of the 3. This follows a wider trend in chemistry, where if there are certain identical objects and certain states they can occupy, then they don't really want them to be mismatched. Basically, since all hydrogen atoms are identical in this case, there is no reason for some of them to have a stronger bond than the others. So what happens? Well, what happens is our 4 orbitals get together and hybridize from 1 to s orbital and 3 p from 1 to s orbital and 3 to p's orbital into the sp3, which looks like this. With these being in the orbitals and such, you can see that in methane, all the hydrogens move far... What is wrong with me? Honestly, fucking hell. Make it get it together.
Do I have this influence on you?
Maybe it. I'm speechless around you, Gatsy. I'm just utterly speechless.
Yeah, I had a dream last night.
What was your dream?
Where we met up. And when exactly as you would expect.
What do you mean by that?
What do I mean by that? I don't know.
Hold on, I need to bring a charger. I also had a fun dream. I also had a fun dream tonight. Except mine was fun in a different way than yours was fun.
Okay.
You had your own fun, I had mine. Basically, I had a dream where I fell asleep, and in one of my dreams, I had a different age than I have in real life. And then I woke up and I was like, oh, I'm not that old, I'm this old. And then after like an hour or two, I realized that I got my own age wrong. Awake, by the way, not in a dream, awake. I got my own age wrong. I had to check. Which is...
Oh my god.
Hasn't happened to me before. But it was pretty funny to... to be wrong about my own age. As I'm pretty certain I got it wrong. Yeah.
Was your age an even number in the dream?
I'm not gonna tell you that.
It's the wrong age anyway. Why does that matter?
There are 3 ages here, and those ages are in order: the age I thought I had in the dream, the age I thought I had in real life, and the age I actually have. And all of them could be used as clues, so I'm not going to.
How is telling you that it was even gonna help anything?
You actually want me to. I don't know why it was so specific, but in my dream, I was in fact 26. I don't know why the number actually appeared, but I was confident of that number. When I woke up...
It do be like that in dreams sometimes.
When I woke up, I was like, oh yeah, no, I got it completely wrong in the dream. And I realized I also got it wrong awake, so... What's baffled me most is that it took me like a solid... Like, genuinely, hour after waking up is when I realized that I got it wrong awake. Like, I woke up, I was like, oh yeah, I got it wrong in the dream. And then an hour after that, I realized... It just weirded me out a bit.
The later experience.
Didn't know he came back, but everyone's forgetting that big oil got to him or something. Actually, he ran it off solar energy, but there's chemicals releasing something into the environment. I mean, nature. Listen, I'm not gonna speak on the environmentalist side because I don't know much about environmental science, but I do know about chemistry and physics. And I can tell you that from a chemistry and physics perspective, what Nature Jab is doing is very interesting. simply because, well, polymers are something that's like really easy in quotes, but really easy to make. And the bigger issue is that they are really good at staying together. They are really good at persisting, but not in the ways we want them to. So basically, you can really easily break a plastic bottle, but it's really difficult to break the polymer chains inside of a plastic bottle. And so this is counter to like crude oil and such, because when you're creating plastics, when you're creating something out of plastic, you usually make those polymers on the thing. Doesn't matter. The point is, chemistry-wise, it's pretty cool. Now, where was I with the video? Let's see.
The p orbitals and the s orbitals.
The sorbitals, yeah, and the porbitals. All right, there we go. Which looks like this, with these being the p orbitals. Which looks like this, with these being the orbitals, and as such, you can see that in methane, all of the hydrogens move as far away from each other as possible, bringing their electron clouds with them, like so. But in But sp3 is not the only one. You can also have sp2, which would look like this. And in this case, in carbon, we're combining the s and p orbitals to create a three-legged orbital, like so. Now, where would that be useful? Well, for example, in benzene, where the atoms look more like this. So each carbon is bonded to a hydrogen, and next to carbons, like so. And here's the entire molecule. Except these are the s orbitals and the two p taken care of. What about the last p? Well, that one didn't. Except those are the two s orbital electrons and one p orbital electron taken care of. What about the last p? Well, that one didn't hybridize, and as such, we still have all of them available. So what they do is they just merge together, like this, and form a ring. And this ring is actually what makes benzene so unique, and it's actually bound by all of these bonds at the same time. And as a small tangent, if you've ever wondered if benzene has double bonds or doesn't, well, these are the bonds. It's useful sometimes to think of them as double bonds that are constantly shifting, but that's just like a model, an approximation, and this is the actual bond. And so by now, I hope you can look at this graph and understand what's going on with each of these bonding orbitals just being a different combination of the underlying atomic orbitals, either interfering constructively or destructively. And that's how we get bonding and anti-bonding orbitals. You can think about it this way. When you have two waves, you can either combine them constructively or destructively. And due to reasons mentioned in the last video, orbitals are waves, so they can either combine constructively to make a more bonding orbital, or destructively to create a less bonding orbital. And in benzene's case, since we have so many orbitals combining together, we get a lot of combinations. So these are possible orbitals. And so that's all the detail about bonds that I'm going to get into for now, or rather typical covalent bonds, because next we have the next chapter. Alright, honestly it's not shaping up to be quite as long a video as I thought, because the metallic bonds, yeah, we're on 16 minutes of recording, and how far are we in the script? Let me see. Page 7 out of 10.
Oh, that is.
So that would be
Honestly.
that would be 20. Well, to be fair, there is still the ionic particles thing that I want to mention, but that would be 24 minutes so far. And let's just say that the cutting I get from getting the script wrong would be roughly equal to the last chapter, so that would be like a 25-minute long video. Way shorter than it seemed, isn't it?
Yeah.
Okay. 3 pages and then I'm done. I don't know why I always put off recording till the very end. It's just a very annoying thing for me to do because I struggle with breath a lot, apparently. All the chemicals in my vicinity just get to me. Okay.
I really hope you can take care of your health better.
I really hope you can take. Anyway, the recording. The metallic bonds, and oh my, this is gonna be a fun one. So, first things first. So far, we've talked only about the atoms from the first 3 periods of the periodic table. But as you go further and further down the line, the rules change. I mean, okay, they don't change, the rules obviously don't change, it's physics, but for chemistry we have the quantum mechanical rules, and then we have like simplified general rules, and as atoms get larger and larger, the general rules become less and less accurate. And so with that context, let's go to metals. The number one theme of metals will be their delocalization. So basically, whilst in something like lithium, when it bonds to form dilithium, it creates a simple sigma bond, this bond... Oh no, that's idiotic. The number one theme of metals will be their delocalization. So basically, in something like lithium, for example, when it bonds to form dilithium, it creates a simple sigma bond. This bond has a specific shape, specific location, specific rules. However, when you're dealing with larger atoms, then these orbitals can come together, and instead of forming just a simple bond between 2 atoms, they all come together and all play a part in this bond, leading to effectively a huge mess. Imagine benzene, but instead of a donut, it's just a vague blob. Now, each time we add an additional atom to the mixture, we get more and more energy levels. So we start with something kind of reasonable, like let's say a 5 for a single atom. Now, if we bring another atom, then we get like 10 orbitals. And if we bring in yet another, we get 15. And then so on, so forth. And each time we get more possible energy levels our electrons can occupy. And the crucial thing here is that this doesn't actually have a limit. So if we disregard the exact figures and just focus on the ballpark, we start with only one energy level, then a couple more, and so on and so forth. So we can keep adding and adding and adding these energy levels until we get a lot of them. Like a real lot of them. And then, there we go. That's metallic bonding. So why? Why do we differentiate between them and the covalent? And why do we think of metallic bond... So why do we differentiate between them? Why do we think of a metallic bond as separate to covalent? Aren't they just the same thing, with covalent just being smaller? Well, yeah, fine, I guess you could think of it that way, but there's a reason to the madness. And that is, as always, energy. So basically, imagine that you have a bond between 2 oxygens. In this case, we disregard all of the underlying s orbitals because they just cancel each other out, and we just get to the sigma bonding orbital, the 2 pi bonding orbitals, and the half-filled anti-bonding pi. Now let's imagine that we add some electrons to our oxygen. In that case, we need to first filling them in. In that case, we first start filling them in into our anti-bonding pi, and then in order to add even more, we need to jump this gap. And that is a pretty big gap. Next, let's look at benzene. In benzene, we have these aforementioned multiple possible orbitals. This gives us more freedom because the gaps are smaller and there are more possible states for these electrons to take up. Then, let's look at metallic bond. Depending on how many ions we add, we can get a lot of possible orbitals. This is what defines metallic bonding and attributes it with the best properties. But first, it's really crucial that you understand this principle. So here's how you can think about it. Imagine that you are a ball, and in front of you there are some stairs. These steps represent the possible energy states, the orbitals, the shapes from before. Now for simple molecules like oxygen, they would look like this. For more complex molecules like benzene, they would look more like this. And then finally, for metallic bonds, since we can add as many atoms as we want, we can just keep on increasing the amount of steps forever until our stairs become a ramp. For you as a ball, it's much easier to scale a ramp than it is to scale steps, so you can pass much easier through a metallic bond than any other. And that is why metals are conductive. What makes metal atoms metallic is the fact that they form metallic bonds. What makes those bonds conductive is precisely this property. So here's where we get to a brief introduction to conductivity. Alright, 21 minutes. What page are we on? There we go. We're on page 8 out of 10. Ah, brilliant. Whenever I read my script without the animations, I feel like I'm rambling. But to be fair,
Yeah, but whenever you stream to 0 people, you aren't rambling.
funny enough, 5 people are still watching. I don't know why. But you know what? Good for you. Not many can take on the unbridled power of my insanity. By the way, this will be a 5 more minute stream, so it probably might be long.
Will it? Oh.
Yeah.
I thought you're done. You're doing the script though, no? Or you...
Like, I'm what?
Come on. Didn't you say you like do the recording at the end of making video?
Yeah.
Well, I guess you have to edit, don't you? Yeah.
Yeah, that's the reason why we're doing 5 minutes. Because animations wise, I'm not that far off. There's this one animation that will take hours to render. But in those hours, I'm hoping that I will be able to edit.
Oh, what is that?
That's a lot of frames with was. I might have overdone it actually. I set it up to 600 frames. And
Oh.
each frame takes how long to render? Well, don't be shy now. Show me the number. Render is a bit shy.
Oh.
There we go. Minute and 2 seconds.
Yeah, so that will be
10 hours.
10 hours.
So I think what I should
Okay, well,
do is I should just stop it right now and then just do it in 2 batches, because I'm pretty certain if I stop it right now.
Uh-huh.
Yeah, okay, it rendered. And oh, I do like that. And it was in fact I need to find some kind of way to speed it up. I do believe 6.9 is where it ended. There we go. So right here. Great question. How am I gonna speed it up? Clamping indirect lidars. 10 non-zero maximum volume in example. High value scale down to avoid too much noise, low convergence. Cost of accuracy. Yeah. No advisor reduce noise at the cost of runtime. 0 for automatic based on number of A samples. Let's do 0 then. Automatic, I trust you. Is there anything else I can do to speed this up? I don't think so. I don't think there is. I could reduce the bounciness to like 4. That could do something. I could reduce the from 32 to 16, but that could actually end up looking like shit. Let's see. What does this look like?
Yeah.
Yeah, I know. Well, didn't help much. 40 seconds. That's gonna reduce it from 10 hours to 6 hours.
That's still much better. That's 4 hours.
Oh, no, sorry. From 10 hours to 7 hours, because it's 45.
That's still improvement.
Yeah, but it looks like shit now.
Hmm.
No, whatever. When have I ever
I've
been...
done 2 batches.
When have I ever been bothered by an animation looking like shit? Okay. Let me splash myself with cold water again, because I'm falling asleep. Oh.
Have you been awake during the whole night or something?
No. But I have not gotten outside of my apartment the past 3 days. That's getting to me. Okay.
I'm a little worried.
Why? It's not abnormal of me, I just had food.
You worry too much about it.
Okay.
Can you blame me?
I actually can. Alright.
What the fuck?
Oh no, I need to finish the recording first. Then I can do all the stuff.
Yeah.
To conductivity, and then the next. Okay, from now on I'll represent our metallic bond with a structure like this. In this case, the height, as always, represents the energy. The width of the thing represents how many electrons the energy state can house, and you can think of it as like our orbitals from before. In our nitrogen molecule, this level of energy can house 2, because it has only 1 orbital, but this energy level can house 4, because it has 2 orbitals. And the reason why you can think of it like the orbitals from before is because, well, these are orbitals. There are just so many of them that it would be pointless for me to even try to represent them. You might not fucking doing that right now. Thank you, jeez. So yeah, each one of these lines is just a bunch of different shapes that our electrons can take, and the higher up you go, the more energy these shapes require. Then we'll have a line like this. This line represents how many of these orbitals are already filled with electrons. So, why is that useful? Well, it's because with this kind of representation, we can already understand bands, gaps, conductors, and insulators. So basically, and very briefly, because I want to make a separate dedicated video just for this, these are bands, these are gaps. Bands are defined by having a lot of space for electrons to take up. Gaps do not. Now, a typical conductive material would look like this, whilst an insulator would look like this. In the conductive material, if you add more electrons to it, you don't need all that much energy in order to squeeze them in. In the insulator, you need to jump the gap in order to squeeze them in, which requires a lot of energy. That's why if you put two conductors together, and then conduct the electron... Fucking hell, what's wrong with me? That's why if you put two conductors together, then if to conduct an electron... No, there's nothing wrong with me. Who fucking wrote the script? Was I drunk back then? I'm just kidding, obviously I was. That's why if you put two conductors together, then to conduct the electron... It genuinely took me like 5 tries on the script to see what I meant when I wrote this. My goodness, accents are really important in speech, and text just doesn't convey it. That's why if you put two conductors together, then if to conduct the electron just needs to jump this gap, whilst with insulators, it needs to jump this gap. A fun side effect of that is that there are no true insulators and everything can be a conductive material if you just try hard enough. If you do actually get enough energy to jump this gap, then you can conduct electricity through anything, and I do mean anything. Then there are also semiconductors and doping them, but that's a topic for a dedicated video. So for now, let's just move on to ionic bonds. Final chapter of the video. There we are, 24 minutes. Okay. Now one last recording.
You can do it.
Yeah. Ionic bonds. So, what are ionic bonds? Well, in order to understand that, we'll need to go all the way back to the beginning, the humble sigma bond. Now in this bond, I've been showcasing it between two identical atoms, most of the time like hydrogen or nitrogen, but you could actually have it between different atoms. And more interestingly, these atoms could have different electronegativities, and as such... sorry, it appears that in all that time I haven't actually mentioned electronegativity once. Whoops, so well, it just means how much any given atom attracts electrons. So high electronegativity fluorine is really good at taking the electrons away, whilst francium is really bad at it. Now back to the bond. What this effectively means is that if we have our sigma bond, then if one of these atoms is pulling more on the electron, then the bond shifts. more towards that atom. It's honestly pretty simple stuff, but what we're interested in is the fact that this basically exists on a spectrum, from covalent through polar covalent up to ionic. So ionic, the name, comes from ions, so we know they're charged atoms, and no, sorry, it appears that I haven't mentioned ions either. What kind of chemistry video is this? Well, ion is just a charged atom, so if your amount of protons is equal to the amount of electrons, then the charges are balanced, hence net charge 0. If it's not equal, however, then you can get either positive or negative charge, resulting in an ion. That's the rough idea. Change the amount of protons, change the atom name. Change the amount of neutrons, change the isotope, and change the net charge, make it an ion. Now, with that in mind, we can take two of such ions, like chloride and sodium, and just smash them together. There we go. Table salt. Or actually, not quite. You see, the reason why we differentiate between polar covalent and ionic is because ionic has a lot more to do with salts, crystals, solid state, whatever. The point is, it goes outside of the bounds of this video, and what stays in the bounds is extremely boring. So let's end this video with a bang, and something a tad more fun, and that is a particle sim. Okay, there we go. That's it. That's the entire video recorded except for the particle sim segment, which I need to get to in order to record, edit, script, and all of the above. The point is, 27 minutes, that's what we need to edit, and our animations end right here at this point. Brilliant. So, now I'm done. I'm gonna be open the window because I'm dying. Okay. Me. We do have quite a fair bit of animations to get through. This is from the metallic chapter, and where did I even finish off? This is the 50-60, which means these two. So add to the end. This is the extremely long animation at the end right here. There we go. Brilliant. Why is something burning? Or am I having a stroke?
Please don't fucking die now. I beg.
Am I having a stroke? Hold on.
Make it. Can you not have a heart attack right now?
No, a stroke. No, it's a. No, it smells like something's burning. It seems to have a direction, so I don't think I'm having a stroke.
Can you locate what's burning in where?
I think it's coming from the outside.
Can you check it right now?
No, I'm just gonna close the window.
I don't want it to fucking explode, I beg.
Yeah, I think it was just the window. I think something's burning outside.
Oh, thank God.
It was a 50-50. It's fine. We landed on the right side of the coin.
Make it, please don't die, for the love of God. I need you to stay alive so badly.
No, I don't smell burning anymore.
Okay, thank God.
Yeah, okay. I have a small first aid kit, but I don't think it would help a stroke. What do you do when you're having a stroke? Actually, what is the recommended course of action?
Good question.
I mean, call an ambulance, that's obvious, but what else? Is there anything you can do, do's or don'ts? Let me see, what to do. Alright.
Yep.
So fast. Make sure dropping out gets pretty difficulty, time to call. Well, I mean, this is like this is just a day for me. That's it. There's genuinely. Oh no, perform CPR if needed.
perform CPR on yourself, can you?
I can. No, I don't think I could. I could just like.
Yeah, this is.
I could just like make like a Rubes Goldberg machine, you know, with a couple of bowling balls, just at the slope.
I think the advice to not live alone for your whole life, you know?
Ouch! I have feelings, you know.
Listen, I'm telling you problems, but there are solutions to them. All I'm gonna say.
Oh, actually, some difficulties to occupation may include memory loss. That's not great.
Hmm. Yeah.
Oh, wait. Some difficulties memory loss. Well, that's not great.
You're so fucking funny. Then I tell you that?
Okay, well, time to make the video.
Meow.
Memory loss. Okay. Oh, that's so loud. Shut up, past make it. Ah, I just. My head. My goodness, that was unnecessarily loud. Okay, first of all, let me fix up all the audio. I'm glad it's recorded now because, well, we can do the typical thing I always do, which is we have like a landmark at the end of how far we need to edit. In this case,
The only person who worries about your life.
no, Miroslava just also said that we need you alive, so yeah,
Oh.
it's, you know.
Okay, well, good.
Parametric equalizer, there we go. Hold on. Ah. I'm sorry, I just got distracted with something. Anyway. I have like 3 more cups of coffee for this to work.
Meow.
Right here we also did the original animation as an intro. Where is it? There it is. Brilliant. There we go. And this is going to take a fair bit. And when I say a fair bit, I mean a fair bit.
You mean 5 more minutes?
There we go. Okay, brilliant. Ah.
What you drinking?
Fucking guess.
Coffee?
Yeah. Well, that's what I'll be drinking. It's gonna
Is it the one you usually drink, or is it like a new one again?
You mean is it Irish coffee?
No. I mean the brand.
Yes, there's the one. I don't ever buy anything else. I probably should. I thought about switching to tea, maybe. But I just.
Mm,
Maybe I should. I have tea. Supposedly tea is healthier.
supposedly.
Supposedly. I don't trust those
Yeah.
liberals. I do have a pretty significant itch. I've had it for around 3 days now to make something, and the I2S microphone has been just sitting on my desk, eyeballing me this entire time. But I know damn well I should be working on a video and not.
Wanna make something. How about you make me happy?
Damn. I don't even know how to fucking respond to that. What do you want me to say? Genuinely, what do you want me to say to that? What am I supposed to say?
I don't know.
Right, don't matter, all matter.
Middle East, huh?
Yeah. I have just been wanting to make something really bad.
Mm.
And I'm having a lot of hard time focusing on the video with the microphone just
Can you
sitting
not?
next to
Can
me.
you not keep doing the mask?
I can. That's the pickle. Like, I can. I have all the things. I could just do it.
Mm-hmm.
But that would require me to
Yeah.
delay the video.
Mm. You wanna rush the video now?
Well, I wanna be done with this bullshit, you know?
Yeah, fair enough.
Those are the real world problems, aren't they? Someone sent me a meme of like Iron Man and just casually Tony Stark tweaking with the Iron Man hand, and I like, damn, I used to do the mask, but then fucking Jesse died and sorry, went to a coma.
Still in a coma.
Still in the coma, yes. Alright, first things first, we're gonna need some music for this. I know you can't hear the video, because if I enable the sound of the video, this all gonna get extremely confusing. And the reason why is because there's gonna be two makers! You won't know which one to shoot. Both of them. Okay, so in this case, I think I'm just first gonna lay out all of the animation. Oh, that's a good idea. I can lay out all of the animations, then I can go the second time, then I can just fix up all the animations, add all the sound effects and everything. Brilliant idea, Make It. Well, thank you, Make It. Yeah, alright, let's do it.
I would make it. I like to make it.
I can make it.
Yeah.
This is really well, actually. Why are the two of these? Oh. Smooth Make It. Fucking smooth. Okay, I think... Yeah, this one was new one, so I just leave this. Fuck. There is a lot of them. There we go. This live stream is gonna be so dry to watch. But it's a 5 more minute stream, what can I do? And none of y'all are talking, so I have nothing to respond to. I'm just gonna...
Oh, I'm sorry. Want me to entertain you more?
Yeah.
Yeah.
Right, first minute, basic edit finished. Only 25 more to go. Good, splendid.
Okay.
It's gonna,
The progress is being made.
yeah, it's gonna just blink and it's gonna vanish. Make it. Would you rather have a clunker that has feelings or a clunker that doesn't have feelings? That's an odd question. First of all, when you say have a clunker, they could occupy a lot of different roles. Like for example, if I have a blender, I sure wouldn't want it to have feelings. That's not great. That's very much not great. If I have a I don't know, a general like house management system, I also wouldn't want it to have feelings. I would like it to do its job. Thank you very much. But if I am like a hypothetically space pirate going on amazing space adventures, and then we have like a robot character as a comic relief, then I think it would fit.
Would you like if Jesse could feel pleasure?
No, no, stop the gross. You're gross, unbelievable. And then people wonder why I don't reveal my sexuality.
You reveal quite a lot. Well.
Oh, it's so good looking.
Just like you.
What did you say?
Just like you.
Just like me, what?
It's so good looking.
Did I say that out loud? I suppose I did.
Oh, the animation. No?
Yeah, right, but the animation, that's what I was referring to.
mm.
Okay. Brilliant.
Oh, it's
2 minutes.
Man.
Splendid.
The summer
Fucking
is soon
hell.
to be over.
There is so much. What did you say?
The summer is soon to be over.
What is soon to be over?
Summer.
Summer. Oh yeah, right.
Yeah.
Yes. Passing time.
I have a birthday soon, man.
Oh.
Yeah.
Happy
On 13th.
13th.
Yeah.
Wow, we share a birthday.
No, we don't. You're pranking me.
I could be. Probably am.
Yeah, probably are.
13th.
You wouldn't know where you were born, considering you don't know what the fuck your age is.
You sometimes forget. How often do you actually keep in mind what your age is? Like, how often do you keep the number in mind? Like, the rough ballpark, yeah, sure, but the number, the actual number. You do forget.
I suppose. If you forget what year it is, you equally.
No, I mean, I remember
you
what
forget
year
what
it is.
fucking-
It's just that the time passes. So, whilst the year I was born in don't change, my age does. So that I need to keep track of.
Yeah. So that's the year that it is also changed, which is also a thing you have to keep track of.
Yeah.
Yeah.
It's too many numbers. Back in my day, we didn't have being born. We just had existence. The concept of
Back
death.
in your day, everybody knew was older than you. I was simple.
Back in my
But
day,
now, kids these days.
yeah, back in my day, concept of death and rebirth hasn't been invented yet. There was just existence in the ceaseless void. That was the time.
Mm. Yeah. Back in your day, grandpa.
Yeah, okay, Grandpa, now let's get you to bed. Make it, when I was your age, I was 2 years older. Right.
Damn.
Although, when you were my age, you weren't. I don't know what to tell you. When I was your age, you weren't. Get owned, liberal.
Damn.
Okay. We're gonna take a bit of a break because I cannot even. I'm having the itch and I keep looking to the side and it's driving me fucking mad. All right, I cannot. We're taking a break.
Was
Yeah, I'm
fucking-
shit. Let's get over it now. Basically,
not that relate to anything.
basically. This is driving
Oh,
me
you're
mad.
shirtless. Oh.
These right here. They are big. Statement of fact, they are just big. And the thing is, right here in one of these boxes, in one of them we have, I think, is it this one? This plus minus, within, yeah, that looks correct. The point is we have Max 98357A. Remember that name. Max 98357. I told you to remember it. Why did you forget? There we go. I looked it up. Now, date sheet and product info. Yes, if you don't mind. Additional details. So I'm looking for the date sheet. There you are. All right, splendid.
Date sheet.
Because in this case we'll have general description. Let's start with this document has 38 pages. I have bought a bit of a
script.
yeah. It's 3 times longer than my script. I have bought a bit of a higher caliber stuff. Okay, so easy to use, low cost in airport communication, digital audio interface automatically recognizes up to 35 different PCM and TDM clocking schemes and eliminates the need for I2C programming. Well, that sucks because I was gonna use I was gonna use I2S. It's fine. Okay. Hi, Zila. How you doing? How you doing? Operations first simplified by eliminating the need of digital audio interface is highly flexible and we're supporting I2S, sorry, it's meant to be I2S, and supporting level justified data. Yeah, brilliant, okay. how am I gonna do this? That's the question. Because I would like to. End of sentence there, by the way. I would just like to.
You like to?
Control them with, I think, pi 0. Pi 5 would be even better, but for now. Last time I you were making some mask and ignored me completely.
How about Pico?
No. Why am I falling asleep? Oh my goodness. I really do need to wake
Why
up.
so sleepy?
Yeah, I really do need to wake up because that's ridiculous.
Man, I'm sleepy too. Wanna sleep with me?
Oh, you almost got me. You almost got me. Almost fell for your devilish schemes. Okay. You read some other guy's chat, but not mine. What were you saying, Godzilla? Because I do sometimes have this thing where you see, Godzilla, among my many mental disorders, one of them is that I am like pathologically incapable of do something people want me to do. So if you join in and you just yell at me to read your comments, I will take every precaution I can to not read what you're writing. That's just something I have. The same reason why I don't respond to backseating quite well.
Yeah.
Or did she say hi? Oh, well, I definitely replied hi. I absolutely always reply hi. Let me have a funk. One singular thunk.
There's a single thought in his head.
Raspberry Pi I2S protocol. That's what we're looking for. You never did. You said lights couldn't be data something. The strip!
Uh-oh.
What did it be an O? What happened?
Oh. No, never mind. I was confused.
Following the other tutorial. What have you done? With Python! I don't want to. I so badly do not want to.
Why not?
It's inefficient. It's annoying to use. Oh wait, what? Adafruit Raspberry Pi install scripts I2S. Hold on. I have some GitHub for this. Raspberry Pi I2S GitHub. Have you all got something maybe? Oh. Device tree overlay. Oh. Wait, that's Linux. What are you making right now? I'm making speakers. Well, not making speakers. The speakers are already here, but I am making the thing that will allow me to use it. It sounds like a relatable case of PDA. What does PDA mean?
DA. Like loud. I don't think that applies now.
Is this? So we need to make sure they unlock sound. How the drivers are disabled. Wait a second. Yeah, so I was correct. That's good. From the Raspberry blacklist config. So we have the config. Okay. Pathological demand avoidance. Intentionally doing the opposite of what people around you do. Oh, thank you. I've never been able to place a name on it.
You have PDA. One more mental illness to add to the list.
Pathological demand avoidance. I like it. What happened with your bonding video? We're rendering a comically long animation for it right now, which is taking absolute ages. Okay. Let me have a funk then. What we should probably do is plug in the Raspberry That's the end of sentence, by the way. Plug in the raspberry. Now, if I'm not mistaken, yeah, it's idiotic. I remember now. Which means we're gonna need a cable, which I do not have, or an adapter, which I do have. Where's my adapter? Katsi, where's my adapter?
Am I adapting to you?
I need my adapter. Where did I put it, Cassie? Cassie, where did I put it? No, Chaco, Emily. Not here. Has anyone...
The adapter box.
Oh, the adapter box. Actually, it might be. That is something I would do. Hold on. Yeah, that's something I would do. Let me check the adapter box. Is one of the letters of the alphabet. Make it. Is Cassie there with you IRL? Under the table, yeah. No, to answer your question, no.
I'm busy.
Cassie's doing stuff. No, Cassie's not there with me. No.
For legal reasons, you have to disclose that I'm not there.
What legal reasons? Am I not aware of something? You better tell me now. Damn it, where is my... I found fucking googly eyes!
In 78 countries?
I found fucking googly eyes! It's what I found before finding an adapter.
Googly eyes?
It's important, like you wouldn't get it, you're not a programmer. I have so many googly eyes. Like, so many googly eyes.
The type of person to attach googly eyes to your normal life objects to personify them more.
You need the googly eyes, they are part of the process. I'm not gonna explain it to you because you wouldn't get it, alright? Honesty is everything but the thing I'm looking for. I'm starting to suspect it's not actually in this drawer. What's this? No, this is the movement detector. Fun. Why did you choose that Jason-looking character as your mascot? What do you mean? You mean me, the European? This is just my rendition of what an average European looks like. I didn't choose it. I made this. I put thought and will into it. No, I'm genuinely finding everything but the adapter I'm looking for.
Yeah, speaking of, you will watch him in the forest at night, would you?
Oh, I get it. I see. See how it is. Not helpful, not what I'm looking for. Shit. Foil, no.
I know where you put it.
Where did I put it?
Did you put it in me?
No, I did. I don't know. Check at this point.
USB to Catchy adapter.
Now, there are so many like discarded things I need to get off my desk. So I no longer use them. They're no longer part of the project.
Your desk is a beautiful mess of things right now.
Looks like Jason, like a European. Jason? Which Jason? Jason is a name. It's not a specific character.
I think they mean like the killer, the guy who kills people.
I'm glad that you said the killer and then provided a definition of what the killer means in case I don't know what it is. No, killer, the guy who kills people. Cheers, Katsi. I appreciate that.
I have a wonderful way of speaking.
I remember accidentally finding this adapter. And then doing something with it so I wouldn't lose it. Oh, the irony of the situation.
Of a misery.
I need the trash can for this trash that I'm
And you just don't remember what you did, do you?
No, I never remember what I did. What I always do is I think to myself, if I was naked, what would I do? And then I do that thing and I find the object. But the thing is, if I was naked, I would have put it in one of these boxes. Which, it isn't there. My industrial piercing is in there.
Maybe the goblins who live in your walls stole it.
Oh, these goddamn savages.
Oh,
No, it's not in any of those. There's another place where I could have put it, but yeah.
okay.
The drawing made the most sense. Because I would have just chucked it in there without thinking.
Is it actively being used on something?
No. It's a very useless adapter that I used once.
What is it?
USB-C to normal USB.
Oh, that one.
Because I just don't have a good USB cable. I have good USB-C cables, I don't have a good USB cable. Is it in the
Why?
candy box? No, it's not in the candy box.
You have a candy box.
Let me try. Make it.
Are you a witch?
Make it. Would you rather have a? Would you rather be a killer or a file type? There's a joke that I can make there, but it is in poor taste, so I'm just gonna acknowledge that that joke exists.
Yeah. You don't wanna play yourself like that, would you?
Yeah, even I have limits. SD card reader, that's
You
what
have-
you need.
You have a low self-respect, but not that low.
What do you mean I have low self-respect? Oh, there's another piece of candy that I didn't include in the candy box. You would be surprised
Oh.
how many companies send you candy.
You should add the googly eyes to the candy box.
No, the googly eyes, you can get it. I could put googly eyes on my knife.
Oh,
On the...
as you kill somebody.
I feel
that is
like
perfect.
on the handle, right? That's where it has to be. Hold on, let me just...
Yeah.
It has to be on the handle, because it would be stupid to do it on the blade. Everyone knows that.
Yeah, if you put on blade, you're gonna slip if you stab me, you know?
No, I might need to put them actually on the blade. Right here on the blade. I need to...
They come with glue,
Yeah.
like a sticker.
We're doing important things on this stream.
You think you're gonna make something? Isn't it making something?
I'm making art. Knifey! Everyone say hi to Knifey.
Nice. A new character is born. This is wonderful. This is your new official box opener now.
It already put husband. Oh, that's good.
Yeah, but now he has a name
Oh my goodness. Oh, this is good.
and iconic look.
There we go. It's
Knifey.
It's Knifey, everyone. It's Knifey. Oh, goodness gracious me. Okay. What do I need right now? Well, what I need is obviously professional help. That's what I need. But an adapter, what are you looking for? Which we cannot find for the life of me. Is it underneath Ryan?
Also, is a line now.
Ryan's fine. Oh yeah. Lost it.
How could this be?
Greetings, Knifey. I hope I spelled it right. Knifey. None of my characters have consistent spellings. It's a big part of them. To this day, most people don't know how to spell Jesse. And I wanna keep it that way.
Well, it's not an official spelling though.
Well, the official spelling of Jesse?
Yeah.
That would ruin the point! Cassie, you clearly don't understand the deep societal, political, and economical implications of Jesse.
Society.
You clearly don't understand the message that the character is trying to convey. The complexity. You think it's just a printer, but no, the complexity of the character is just...
Wasn't it me who came up with that name?
Was the what?
Wasn't it me who came up with that name? Anyhow. Complex numbers. Actually, I find it quite simple. What do you think you will say? Which postmodern love song is that?
No, this is APT. It was not for more long. I just did a stroll around my pub and cannot find it.
Is it the meow 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 song?
It is the meow meow meow, but without the meow meow meows.
What the hell? That ruins all the fun.
Bad news. I cannot find the adapter, which means we're gonna have to use a USB cable. Ugh. I know, disgusting. Even worse, my longest unused USB cable is about kind of this. I do have another one. Hold on, let me show you the other USB cable I have.
Over USB cable. That is not a very long cable.
It's average. It's the average. If you think this is not a very long cable, then just you wait. That's because I have this USB cable. That's the first one, entire length, and then also I have this cable, which is a fair bit shorter. They're my two USB cables. So
damn.
I think I can use this. This is like twice the size of the Zero. So unfortunately, Zero will have to be on the side, and you won't be able to see it. You will just know that it exists. Oh shit! Which one of them is power? It's probably.
Now wait until you show us your USA cables.
What's that even supposed to mean? Okay, the outer one is... Oh wait, this one doesn't have... Oh, this is the development one. This one... Okay, it's glowing. That's good. Now, in order to connect to it, what I need to do is I need to... Well, connect to it. SH. Maybe isn't the name of this kind of PO? I don't know what PO. I know what PO stands for. Welcome back, B. How you doing?
Meow.
Okay, splendid. Now. Which one was it? Good question. Hold on, let me try to figure it out in the background. Cancel, close remote, yes. The actual remote we want is this one? The one... Oh, what would be my password? Is this my password? Can it even connect? Hold on. It's connecting. Give it a second. These are, by the way, so like chunky, so massive.
You know a lot about that.
I'm sorry, but the knife of the googly eyes is killing.
It is made for that, yes. It's supposed to be killing.
It is so sociopathic. Do you have a hunting knife with googly eyes on? I'm just looking at it and losing my mind. Okay.
You should walk with that outside.
I already did. Oh my goodness, I think it connected. Hold on, did it? Oh shit, it did. Okay, brilliant. So now...
Do we have a connection?
Hi there, Adrian, hi.
I mean the pie.
Why is Adrian a different color?
Is he?
Yeah,
What color was he?
he was brown. Now he's grey.
Oh, he's no more brown.
Oh, that's a cute knife, what's his name? It's Knifey, obviously Knifey. I feel like we
Knifey, has
could
to be
come up
Knifey.
with some other more creative name.
Well, are you known for creative names?
Yeah, have you heard of Kenergy?
Yeah, that's Jack and Danny.
Oh, right. Jesse is good.
Yeah, Jesse's good.
Could be a nice name. Jack Stauber.
Like the guy.
Like with stabbing. Would be
That is a...
Caddy is my code, so I can't call it Caddy.
Well, we all have a Jack. That's a problem.
Only one of the eyes is like drooping. It was
Stubby.
Tubby.
I said Stubby. The killer?
So pretty. Right now, I would just like to point out that we halted the entire stream just to come up with a name for a knife.
How about Mike?
I like Mike, and I don't even want to know the reason why Mike. Just Mike. I don't care. Just Mike. Done. It's Mike. It's just Mike. Mickey, do you remember your friend the statue? Of course I do. You don't forget that old relationship, you know. Okay.
The statue?
We're connected.
Oh yeah, the statue, of course.
We are connected to the thing. Mike the knife. Yes, Mike the knife. What do we need now?
Yes, Mike.
Okay, here's what we can do. We can go up, etc. I guess. Would that help? I don't know if that would help actually. How do we figure out if we have... If we can use, okay. Raspberry Pi I2S. Yeah, how do you do this? Shut up. Yeah, there's another one I'm looking for. Firmware config. Ah, I see. Okay, so cd up, cd boot, firmware. Alright, splendid. Now codes. Can I just open another code? I can! Oh, how useful. Do I need to also add... Oh, I need to give you my password. Alright, fine. Is it redoing two connections? Because that's comical. How about Greg? No, Mike is already taken. Yeah, it's already Mike.
Mike is taken. And also Mike is taken.
I had Mike has been mugging people for his blue addiction money. No, I need to get my blue.
Yeah. More blue.
Okay. Let's uncomment this. Wait, permission denied. How about you piss off? Oh wait, no, I need to do this, don't I? Save as root file not found. I am going to lose my mind.
Do you have any left?
I cannot say this. I am fine. Don't save, whatever. How am I supposed to edit file? Do I really need to do it with SSH? Fine, I'll do it with fucking SSH. Yeah, whatever. Permission denied. I am going to strip you for parts and turn you into a blender. CD up, CD boots.
Can you strip me?
That's you can only do that yourself. Make a do you play chess? I have occasionally been known to play 5D chess. Not the normal game. I suck at the normal game. Sudo.
Yeah, he's so bad at normal chess. I beat him every time.
Sudo config txt. Okay, and then right here we have this, which we want to comment out. Right. Enable optional hardware interface. Yes, so now we have I2S enabled. Splendid. Make it, have you ever played Balatro? What even is that? Balatro?
No.
Haven't heard of it.
Would never.
Oh, we need to reboot it now? Okay. R code.
Well.
Brilliant. Okay, this is good. This gave me nothing. That's splendid. We will need to apparently. Yeah, apparently we'll need to plug it in right away.
Okay.
Hold on, I'm thinking too much.
You're having a funk.
I'm having a very powerful thunk. That's a good question, actually. Let's do Raspberry Pi play a sound with I2S. I'm curious. I will even take Python just for this. Yeah, okay. So we have Pi 5, Pi 0, this is audio decoder. A DAC? I do have a DAC. Oh, there's like a dedicated DAC. I don't have that. Oh goodness, no, I don't have that. I do have this. I think might even have the same one. Let me just check real quick. It's in one of my. I have 5100. Yeah, so I have this. Okay, good. PCM pins. Okay. So pin out XYZ, and then it's gonna be PCM. We only have one of each. This could be bad. Make it. You've played peasant version of chess. I don't know what the peasant version is.
Peasant version.
The question is no. This does have din and doubt, which means it is going to be It could potentially with both sides. Kind of like cutsy. Now, we take this. Find frequently depending on the type of by using. Okay, so this. We pop off them in. I don't want to set up anything permanently though yet. Because if I set up permanently, I'm not gonna struggle. Which means I should do it on the breadboard. The only pickle is that my Pi Zero is plugged in off screen because fucking the cable is so short. I don't have the adapter. Do I have a longer cable somewhere? What's this? What are you? Give me. You're a camera. I don't need a camera. What is this? This is a... wrong USB. Yeah. No. What are you?
You can also zoom out the camera a bit. I was trying to show you some of your gorgeous body, but you know.
No, because I'm doing shitless, right? I can't zoom out that far. It's off screen, in fact. Damn it.
Okay.
I wanted to do something fun. I'm really struggling. Make it. Does Katsi have a YouTube channel? Katsi, do you have a YouTube channel? Femboy Physics.
No.
Look it up. Let's go.
Do you want me to have a YouTube channel?
If you could be the new Femboy Physics, because Femboy Physics isn't doing videos anymore. Don't ask me how I know. I just am aware of that.
Fanboy Physics.
Yeah, but they stopped doing. They only made like a couple videos and they stopped.
What is Fanboy Physics? Fanboy Physique. No, that's not what I'm looking for. No. YouTube.
Okay, in that case, I would need to find a cable in order for me to work on this on stream. So I guess, yeah, I guess for now we just end it here. Whatever. Had my brief break of having fun. Time to get back to work. Wait, 40 or 50 chess? You are lacking the first part of the question because that's not a question. What do you mean 40 or 50 chess? In what context? Yeah, you do need only an account, you don't need a channel. You made a video on it, didn't you? Yeah, I did make video on 5D chess. Right here, what we need is we need this.
Wait a second. Mega, I want to share a fact with you.
What the fuck are you gonna share with me?
Fanboy Physics has a Twitter, and they have posted very recently.
Do they have a Twitter? I mean, I'm not gonna lie, I don't have it. I don't. Wait, first of all, how did you find their Twitter? It's not linked.
They have. It is linked.
Oh, it's linked in the description. They have a Patreon.
They have a Patreon.
Oh, isn't support? Okay, but no, they're not a creator. Doesn't matter. They do have a Twitter.
Well, and they've said some. They've said some posts in the last.
I don't have a Twitter account.
Actually.
I can't see them.
Can't see them. Oh.
Also, it has a fan account tag.
Yes, but it also I came here from the link from the channel, so
Fair point, I guess.
it cannot be
But
like,
yeah, I cannot. To me, it says Fanboy Physics hasn't posted.
Oh, to me they have to post
Yeah, because I
122 hours ago.
Hi, the Bionet. I think this is freaking what I have to do once I understand. It's not hard, it's just boring continuous steps. Just do Control C, Control V. I agree, Adrian. I do agree. I'm trying to know that because I was interfering on the democratic process of one of your posts making your kind of YouTube channel. So you're the reason why the streams have been so boring. Mr. Mickey, why is Katsi in all your streams? I don't know. Ask Katsi.
I'm not in all of your streams, right?
No, there are a couple where you're not.
Yeah.
How are things? Business is booming.
Listen, I'm just really into make it, Like the way he streams is just so compelling.
Punch the other thing, just. Okay, this. This.
So silly.
Make it the way they did once, sure, yeah. Sure. Wink, wink, nudge, nudge.
I know, Adrian, right? Half the reason I'm here is I just attract so many viewers.
I feel like the sole reason why Caper is patron is because of you.
Listen, I'm helping make it all the way I can.
That sounds like a euphemism. Oh, fun fact! When I was rendering this, that's when we had our make it real from the phone, the made breakdown. Hi, the Caper. Oh, speak of the devil.
Keeper of the devil as of a person attracted to me.
Genesis Land Katsi is apparently a reason for my patronage. You do mention it quite a lot how you worked for Katsi. Hey, I'm not gonna blame you. That's the reason why I'm here. Okay. Science twink. I'm a sylph.
What the fuck is a self?
No one here a fan of the Don't Look Up? No one? How DiCaprio know the Don't Look Up, the crucial scene where the science duo is talking about the comet that's about to hit Earth, and then the sylph beam. No.
No. I'm sorry, but no.
This is I'll just no. Okay.
Nah, I'm doing this for free, for the love of the game. What's I doing? Oh. Well.
Yeah. Ah, brilliant. Make it, what phone do you use? Why are you so interested in that, Godzilla? Just why? Oh, here at the Classified Club. Well, the cats is found is called the Meowers.
I find that girl a little bit gays.
Does make it count as more than one person. My experience is so broken. Yeah.
You love distractions, don't you?
It's right next to me, don't we? Whenever I don't want to mention that, whenever anyone mentions like schizophrenia, mental or something like that, that theme is playing in my head. Although gays do slap as well. Yeah, but you do need to pay them extra for that. I found out the hard way. It was quite hard. Zing! Damn, I'm on a roll. Alright. Damn, I'm so funny.
Yeah. That's what. Yeah.
This and this. That's when we can go for the LGBT lobby. No, I have to pay for interest again this month to be featured in the credits as such. Sorry about that. I need the money.
Yeah, he needs the money more than he needs food. He needs to buy such.
Don't say well. Don't say. I'm gonna spend this money so much better than you. My alcohol will be so much more important than your bread. Yeah. By the way, Kepa, you missed so much on the first half of the stream because, like, let me summarize it for you. Yeah, I do believe that pretty much sums it up. Okay, back to the video.
His name is Mike.
His name is Mike, yeah. Oh, 3.5 minutes. Alright, we're cooking. We're cooking, good looking.
Now we're doing gasoline.
This is indeed a VOD I'm waiting to watch. There's absolutely nothing there to rewatch. It was just... It's just a knife. It's just a knife with googly eyes.
Well, actually, there is a couple of frames of Circle. Let's not make it.
It's unbelievable. Oh, right here is where the images should go. That makes sense. When the meow is LGBT or lobby roll at make a server. Yeah, I could genuinely just do it with Ballot, couldn't I? I keep forgetting I have a bot. I could just like give it the thing so that if you react to it, it just gives you the roll.
Mm.
But that's so much effort. That would take me 20 minutes.
As opposed to every other proactive thing we've done this stream.
For this stream, remember how much time I spent on the blue and orange meme?
Oh yeah, I was probably yeah.
I could just spend 20 minutes on it and be done. 20 minutes I could be used making videos. Yeah, or putting googly eyes on knives. That is so true. I agree.
Yeah. Or looking for a USB cable that doesn't exist.
I would just like to mention that me putting googly eyes on that knife and looking for USB for a USB adapter, I did count as my break. Like that was me resting. I'm good now. That's what I'm editing.
Rest. Well, my next rest would be the Discord roll about.
Yeah, exactly. That's gonna be the next break.
In my free time, I do programming in Python. Amazing.
I mean, you're joking, but like, I do want to be done with this video mainly so that I can get back to working in the mask.
Yeah.
I hate like when I don't get to when I can't work because I'm working. It bothers me. Every stream drains a little bit of my sanity only for a video that pressures fully. Quite a cycle of life over here. Welcome to the club, Caper! Well, fully overstatement. Or replenish is an overstatement.
Well.
Oh, there we go. We've gotten 4 minutes! 4! Yay! How's the animation? It's not even halfway done. Brilliant. Good! Is it still going at 45 seconds per frame? Yeah, usually people are used to 45 frames per second, not 45 seconds per frame.
Mhm.
Why can I read? I know it's a curse, real curse. I did update Bunnet today. There's like there are a lot of features you can do through an API that you cannot do normally. For example, did you know that you cannot actually ban someone in normal Discord unless they are on your server? Like they have to be on your server in order to get banned.
Mm.
But through an API is no problem because through an API all you need to do is give a profile. So you can ban people who have never joined your server.
Interesting.
Try later, I'm gonna show you stuff. See you later. But then on the Brown Adrian account. That's not a... You found the worst thing to call it, honestly. You've clearly picked the wrong dialogue option.
You wrote that as your own charisma check.
Here's the question. Should I make myself another cup of coffee or should I genuinely try being healthy and actually try doing the tea thing?
I want to see you do the tea.
Because I feel like after 6 months of drinking the same like cheap garbage, it could genuinely take a toll on me. I did like very casually accept that I might be having a stroke on the beginning of the live stream, which is not a great thing, is it?
Yeah.
Also gonna remember counts per API, which is useless for small service. Approximate member counts? How do you mean? Okay, there we go, there we go. We are at 4:35. Now, we will need to make another run at the entire video once we're done with editing it. Well, not editing, only placing the animations, because once we place the animations, then we need to combine them all together. Then we need to add music, sounds, all these things, edits and such. That'll be the second run. Member count for a server and the guesstimate of this number, both server set by the API. The exact member counts for a server and the guesstimate. Can't you just do that without the API? Doesn't Discord just show you this? Where did it show it though? It was like in some kind of idiotic place. I remember somewhere it showed like a amount of.
Yeah, I feel like it should show you now. Because you can probably see like every member. You can just count them, no?
It does, but bot can't just read that. It has to fetch it. Like, yeah, it makes sense, but isn't that just how APIs work? Like, usually when... I don't know what APIs have I used in the past. Let me have a thunk. I did use a YouTube API at one point. Because I was uploading so many shorts. I was making clips out of my YouTube live streams. And goodness gracious me. So you have the choice to get the exact number and a fucking guesstimate. What does guesstimate mean? Wait, what do they mean by a guesstimate? What is a guesstimate of a number? How do they get the guesstimate?
Number.
I'm confused. How do you get a guesstimate of a checkable number? I know what guesstimate is, Miroslava. That's not what I'm asking. That doesn't seem like a number that can be guesstimated. I am so confused by that. There we go. It's faster than the exact number? But how would it be faster?
Wow.
How would it guess, like, from a computer science point of view, how do you guesstimate it? So we count approximate number of members in this guild from get yields. What does an approximate number mean? How do they get an approximate number?
How do you count approximately?
Like, okay, there is one way it could work that I have an idea for, but it's kind of dumb. There is a way with the server structure where when you have a globe spanning system. When you have a globe spanning system, then there are multiple servers that operate, and basically they can at different times have different values for the same value. The most common example is like the YouTube views, right? So when you it would be a huge waste of computational power if every time someone looked at a video, it had to actually count every single person on the planet has seen that video. So instead, different servers have different caches of how many views that video has. I think Tom Scott even made a video about that a while back ago. The point is that could be the difference between the exact and approximate number. That is, the exact number is the servers doing a full specific recount, whilst an approximate number is just the cache. That is the only explanation I have. I don't have any other. I don't know how else it would work.
But like the server has to know how many members there are, so the number is there.
Well, it could be just the cache, which would fairly make sense. Like so, here's the thing. At no point is it actually practical for Discord to. How should I put this? Okay, imagine there are 3 servers, right? Australian, European, African, for example, right? 3 Discord servers. Now, when a new user joins in from Europe onto a European Discord server, then the European server would take care of it, right? It would be inefficient to right away alert the African and the Australian server of that, since they don't actually care. So what you could have is you could have all the servers update their amounts once a day, and then depending on the time of day, the counts could be a bit. I don't know if I'm explaining it that well. Like, imagine you have a Discord server with 1,000 members, right? We're gonna have 3 servers: the European, the African, and then we're gonna have the Australian. There we go. Let's say the European thinks there are 1,000 members, African thinks there are 1,000 members, and Australian thinks there are 1,000 members, right? Now, if a new member joins in from Europe and connects to the Discord server through the European server, then the European server will be aware of that. So the European will update it to 1001. But it could be inefficient for whenever that happens to the European server to update all the other ones, right? So it just doesn't have to, and then the European server would just keep the figure of 1001, African would keep 1000, Australian would keep 1000, and then just once a day they all update each other and recount, which would lead to 1001. That could be it. I'm making a guess here. I'm not saying that's what it is.
Yeah.
I'm just saying that this would work as an explanation, because then the difference would be that the approximate member count would be faster, because you only need to ask one server that's the closest to you, whilst the actual member count would require you to communicate with all of them. And that's why approximate would be less accurate than the total. But that what happened, I don't know.
Alright.
I have made myself some tea. I'm just getting a spoon. I did add sugar because I'm a masochist. I'm merely a sadist. Okay, there we go.
Tea is fine with no sugar.
Yeah, because you are the masochist. There we go. The script in here doesn't exactly match what's happening on screen.
Are you gonna fix that?
And what?
Are you gonna fix that?
I don't really have how, because I would need to either remake all of the animations or write the script. So no.
You can't rewrite the small part, can you?
Like, the thing is, it doesn't miss much completely. I'm talking about the same thing. It's just the animations could flow better.
Oh, okay. Who must?
It is I.
Hi, the macaroni. How you doing?
The pasta guy.
Yep.
Am I wrong?
You know, for the fact that I call myself macaroni, I don't really have anything with pasta in my bio.
I just spent 30 minutes to realize the derivative of an integral of a function is the function itself. Not quite.
Oh my God.
Offset by a constant. Very important. Because you do lose the information of the starting point.
Yeah. When you do derivative, like, yeah, you piss off some number.
Derivatives gives you the rate of change. The integral gives you the total sum after the rate of change has been applied. But when you take a derivative, you lose the information about what is the starting point of the function, because no matter where the function starts, its rate of change is the same. I can even show you. Make its tangent. Brilliant. That was quick.
It do make sense.
Make it has made it make sense. So if you have, for example, something simple like x3 plus 7 x2, actually let's do minus for the sake of it being nicer, plus 3x minus 2. You have a wacky function like this, 7 might be a bit much. Let's do 2, 4. 4 is fine. There we go.
Yeah.
Equal to this, and let's do a at the end actually for reasons, foreshadowing. No constant in the original function, it's just fraction that integrates into a natural log and the derivative by the fraction. Also, why is it preferred to use trig when integrating, say 1 divided by square root plus 1 instead of natural log x squared plus 1? What? Why is it preferred to use trig when integrating, say... Hold on, because I'm confused what you're asking. Those two things are completely different. 1 divided by x squared plus 1 and then natural log of x squared plus 1. Okay, well, in the meantime, as you're wording it the way you want to, I'm just gonna get back to animating. Well, not animating anything.
Yeah, unmade these balls.
So what?
Sorry. Cardi right there.
In this, you can't hear it, but in the script, it just says we start filling them bottom to top. And that's why I'm always that's why I'm always left last. Interesting thing I had today is that the European Union can be considered as a country in which state has more power to the center of government.
What?
Huh? More power to the center? You mean like America if it wasn't federalized? Is that what you mean? Because yeah.
Yeah.
Kind of
Yeah.
union of countries sort of thing. Yeah, that's why it always bothers me when like Europeans make fun of Americans for not knowing European countries, when those same Europeans cannot name more than 4 American states. Like a state, if it's the size of a country, it bothers me. It vexes me.
It versus you.
It does.
And you're an European who can't name either.
Yeah. I feel like I could be able to name more states than countries, though, because there are just so many more states than countries in Europe.
Well, in European Union, maybe. In Europe, though.
How many countries are there in Europe, Katsi?
A fucking number. I can name them all, but I can't tell you a number.
I asked you as in look it up, but whatever, I'll look it up. How many countries in Europe?
37. Bet.
44 to 50.
Ah, fuck.
37, yeah, so it's either less or slightly less.
Okay, well, yeah.
And my
But
ass,
not
someone can
less
name
than large.
44. If you can name 44, then you need to find a different autistic hyperfixation, in my opinion.
So true.
I can name like
I can name like 3.
yeah, I can name like probably all of them.
France, Germany, and Edinburgh.
What? Don't you mean
Okay.
Embra? Hi, Ninja BM.
Glasgow.
Do you mean? You have a license on that?
Edinburgh, Glasgow.
Do you have a license for the permit? Do you have a license carrying permit?
Graph 100 can name all European countries. Who's Graph 100? It's popping. Hi, the ninja. How you doing? I keep playing with the googly eyes. I need to stop.
The googly eyes. You should play more with me. My eyes. What? Maybe not.
That sounds more like... I know you all haven't seen the Sandman, so you won't get the reference, but just me pointing out the Sandman would be enough of a reference. Glasgow and Scotland. Edinburgh is a capital city. What? I have no idea what you're even referring to. Edinburgh is my favorite country. Let me phrase. Graph can name all European countries 100%. That doesn't change my question though. Who's Graph?
Fascinating. This vexes me. I can name all European countries. It doesn't mean much.
You can name all 50 of them.
Yeah.
Go on, floor is yours.
Okay. Are you gonna count them?
Yeah.
All right. UK, France, Spain, Andorra, Montenegro. Fuck. Doesn't matter. Okay, what's the other one? San Marino. Is Monaco a country? Fuck. I think it is. Yeah. Monaco. Italy, Vatican, Liechtenstein, Luxembourg, Belgium, Netherlands, Switzerland. Did I say Luxembourg? I did. Germany, Austria, Denmark, Norway, Finland, Sweden, Russia, Poland, Belarus, Ukraine, Latvia, Estonia, Lithuania. You know what I fucking meant. The Czechs, Slovakia, Hungary, Romania, Bulgaria, Greece, Macedonia, Montenegro.
You've already said Montenegro.
I know, but they are in the same pile, so I'm saying it again.
Wait,
Serbia.
hold on, before you keep going, because you are at, I believe it at this point, you're, I think, at 35. Is this
Alright.
the lyrics from the song that you're just, is that how you remember it?
No, I'm just imagining a map and I'm going through them as I am,
Never mind.
Autistic hyperfixation. Get a better one.
Hi, Darunko, by the way.
Hello.
The real challenge, can you name countries in fucking Africa?
South Africa? You're welcome. Look at all these losers being number 1, 2, and 3, and they can't even join the live chat. I'm just saying.
Pretty sure that's why they're number 1, 2, and 3.
Pulling rank on the peasants.
And they're not even blue either. Like, I can just do this and there is ultimate power. Like, I think they should be more aware of the hierarchy in place.
We are just letting them eat cake.
Make it. Did you see my snowman?
Snow, I did see. I don't know if you've even seen. I reacted to it. Yeah.
Oh my
No, I didn't. I wasn't in chat.
Oh,
Where?
not in chat. I mean, on Discord, I reacted to it because I knew you weren't on stream. So I
Wait,
just
what?
yeah, I gave you a fire reaction
Ah,
because
Oh.
I wanted you to know that I saw your snowman.
The
I did not get
snowman.
notification for that. I'll blame
Mm.
Discord.
My thought was obviously more.
But I have
What's
good
this?
news.
Well,
Uh-huh.
what's the good news?
This snowman is the basically manifestation of my thesis. So I'll be seeing a lot of snowmen.
This is what
Okay, well-
this is what physicists will do and call it mathematics.
You know what? The last three are not even relevant because all the contributions vanish. The first one is relevant, and it is by a process of melanification. Melanification.
What?
Sorry.
I'm not kidding when I say melanon. How do you even pronounce that? Melanification. Melanification.
Like a melon, like the fruit.
Yes, because if you look at the top image in the first diagram, you have two propagators up and down, and in the up propagator there's like another loop circle.
Yeah.
It looks like a melon.
Is that genuinely why it's called the melanification?
Let me get it to you better because I have another picture. I think I sent that picture. Hold up.
Really? That's that looking like a fucking melon.
Let me send it to you in which chat? Which chat was this? This was in the memes, right?
Yeah,
memes.
science
memes.
memes, yeah.
Look, this is literally called
Melonic diagrams, holy shit.
And it gets even better because they were using a phrase which just killed me inside.
Melonify.
Oh my
let's
God.
let's melonify this line.
No, it gets better. It gets better. Look at this.
Okay, hold on. Melonic dominance is a characteristic feature.
This is my new favorite phrase.
Melonic dominance. Melonification is so awesome.
Oh, melonification. This is.
The whole reason for this is that only images or diagrams that look like the melon actually contribute. So all the other are irrelevant. So we only care about the melons.
I want to make a meme right now with the two soy arguing versus the two chads arguing, and like the soy are like medicine, and it's like, oh, what should we call this disease? Well, it stems from these cells and this reaction and this. We need to combine the words. Meanwhile, physicist, what should we call this? Well, it looks like a melon.
If it looks like a melon and sounds like a melon, it's probably a melon.
You and I spread my melonic dominance.
Melonification really got to me though. That is. I mean, I get the melonification right here. Yeah. So this is like, yeah. So I see. Is you get one. I'm guessing topology related.
No.
Not
Not even
really.
topology related.
Not even topology related.
No. The lines are just propagators.
I'll go
So
for Nova.
and the dots are interactions. So
Wait, hold on. So what is? Okay, could you give me an example of what melonification is?
Melonification is just if you have a propagator, which is just a straight line in the figure 2.5. It's just a straight line. You can induce an interaction, and the only type of interactions that are admissible, or at least have a non-vanishing contribution to the self-energy or to something, like to the physics, is the melons. So it's just you change a propagator, you just add an interaction basically. And the melon is the only allowed interaction.
Let's just say hypothetically, I don't know physics. What is a propagator?
Oh, it's just a propagator is just a mathematical tool to describe how for example, electron moves. So
Okay.
it's just you can see the line as an electron going from left to right.
Okay.
That's it.
Okay.
I forgot propagator was a physics word.
Okay. That makes sense then.
Yeah,
The
so,
three
so
lines.
basically the single line is just a particle moving without any forces acting on it or without any
Right.
interactions. So it's just a free particle.
Right.
The right hand side is that same particle, except now you have some basic interaction. And like for example, in electromagnetism, this might be just a photon being emitted or
Is it
absorbed.
is it a different way to describe it from a Feynman diagram? Because
No, this is a Feynman diagram.
oh, this is a Feynman diagram. Okay.
Yeah.
Yeah. In that case, that makes sense. Actually, this is like, yeah. I am
Yeah, but-
confused by three lines. That is what confuses me.
Yeah, because we are dealing with Grassmannian something variables.
Fine.
And-
I'll take it.
And we are in 4 dimensions, and you need to have an antisymmetric coupling matrix tensor ish. So that's why you need 4 points leaving a vertex.
Okay, it makes sense in that case. Well, it doesn't, but you know,
It's as much sense as it's gonna make.
it very much doesn't make sense, but makes sense. Who's the smart one? That's Remco. That's well, which part actually? Oh, I have an idea. You can remember Remco as the guy with whom I have I don't know if I should even call it a bet. A deal. A deal is simple. You see complex thing. I have 18-year-old whiskey that I have had for years at this point, unopened, brand new. Well, not brand new, but unopened.
So it's more than 80 now.
Yeah, at this point it's like I don't even know how many years it has.
25?
The point
my
is,
God.
I have old 18-year-old whiskey, and I have a deal with Remco that I'm gonna drink this 18-year-old whiskey with him, and all he has to do is just win the Nobel Prize. That's it. And that's
Literally, I can do this in my sleep.
yeah. Honestly, it's not like if. It's more like a when question. It's not like if Remco wins the Nobel Prize, we're gonna drink it. No, it's when Remco wins. I have such confidence. I'm just keeping the bottle unopened because I'm just waiting. Like that bottle is not gonna be wasted. I'm just waiting to open it. Whiskey doesn't exactly
Hello,
age
shut
after
the fuck
bottling.
up.
We
It's
fucking
25
know.
years
Shut
old.
up. Oh,
Exactly.
I'm sorry. Fun police. Oh, I didn't realize someone called the fun police. Oh, 911. Oh, I'm sorry. I would like to report some people having fun. Can't even drink. Can't even drink and drive anymore in this society. What happened? Do you like?
So true.
By the way, did you like my Hambu Jack picture by Remco? Oops, hold on. That clicked on the wrong thing. I meant this one. Hambu Jack.
Show me.
I spent
Oh, yeah, I
Such
did.
a-
I want.
such a comical amount of effort on this. This LED there is like a light of God.
I want my whiskey to be as divine as this one.
This is the physicist. This is the physicist's dream. This is the physicist's
Yeah.
origin story.
Yeah, but now the whole thing is that I want this LED inside of the bottle so that when I pick it up, it's still glowing. And you need to put in some golden sparkles. So
I did make like a cover. No, the cover. The opposite of a cover. The undercover. For my glasses so I can drink glowing stuff because
that was such a good topology joke, and you won't even know.
I don't like apology.
It's a cover. No, it's an uncover.
I turned off the Jack image and I just got hit with the melodic diagram again. Drinking and driving is bad because you risk spillage of your drinks. You stop drink and you stop drink and get back to driving. That is true.
Commas are important though. Please use them.
That is yeah. Without
First
the
official
comma,
warning.
you just said you stop drink, which is just very idiotic
Yeah,
sentence.
That's heresy.
Yeah, you stop drink. No.
No, we won't stop drink.
Commas are important. You either stop drink and get back to driving, or stop drink and get back to driving. Very important. This looks like a melon. I cannot even with this.
If I find any updates on this, I will give it to you.
Oh, thank you. I needed
Wait.
this. This is
If
giving
you want, I have an interacting lemon for you.
lemon.
Melon.
Oh,
Those two
I
words always fuck me
genuinely.
up.
Oh no, I genuinely thought that there were melons and lemons in this.
No, only in my mind.
Oh damn it! I wish. I mean, wait, they could still have 4 points. Like, hold on. Hear me out.
If you understand that, you're getting my Nobel Prize.
Hold on. Hear me out, okay?
The
Like,
deal is only valid for 5 minutes.
listen. All I'm saying is, no, we couldn't have a lemon. I take it back.
Yeah,
Could
the
be.
lemon is a melon.
Can...
Topology.
Shit, no. No. This universe sucks. This is garbage. This sucks.
Complex thing. By that definition, the ocean is a continent. I'm not sure what
but
you mean
you-
with covered by water.
I can understand why Europe is a continent. The Russian continent is landmass covered by water. Yeah, I. I don't think that's a great definition for a continent. A landmass covered by water actually expanded beyond geography, even. Europa, the celestial body, my favorite continent.
The celestial body. Yeah.
Covered or surrounded. That is also good. Yeah.
But in that case, it could be true.
Yeah, but I don't think continents are just a landmass is surrounded by water, because in this case, every island would be a continent.
Is an island a landmass? It's not very massive, is it?
UK, my favorite continent. Or Ireland.
Malaysia.
That's not a land.
You're so right. There is no land. The actual definition of what makes a continent is, I do believe, trifold. Because there's the geographical, geological, whatever the proper name there would be, and then I think societal. I don't remember the third one.
Cultural?
Hi there, Theo.
Yeah,
Hi,
Theo,
Theo.
you just missed us looking at melons.
Theo would so much love this. We go back to melons.
Okay,
Show them.
hold on,
Show Theo the melons.
The melons, the iterative construction of melonic diagrams.
Also known as melonification.
Looks
Melonification.
like a melon.
It must be a melon then. And the melonic dominance. Actually, hold on, what is a melonic dominance?
No, that infers to the fact that only melonic diagrams contribute.
Oh, so only if something
every-
isn't a melon, then it cannot. That's not relevant.
Yeah, it's not relevant to the self energy because it fades.
So melonic
It
diagram-
scales- all the other diagrams scale as 1 over n, and we always want to take the n to infinity limit.
Okay, so
Yeah,
so the melonic diagrams are the only ones that don't tend to zero.
yeah. They tend to a constant. And this constant depends on the coupling strength. Hey, Theo, and also bad person. Hi.
Hold on, but you just say it tends to zero. Why am I? Whatever. I spend like a
No.
solid hour non-stop working.
This is where I'm getting my Nobel Prize, so you should be invested.
Yeah, no. What I meant is that like I technically it's a 5-minute stream, so I should be working in the video. But you know what? No, I started the stream for working for like an hour. Then I took a break to work some more and put some googly eyes on my hunting knife. This is my break number 2. I'm taking it. Well, I want to learn about melons. Okay,
Hey, tell.
so
What do you want to know?
in this case, lines you say are the just propagate what? I'm bad.
Propagators.
Propagators. There we go. I could figure out.
So close yet so far.
Propagators. Okay. So in this case, this would be there is no time in this, right? Graph.
Well, technically, a propagator has to propagate in time. So 1 point, like from
Okay. So
Right,
left,
but
right,
in the
right,
same
left.
way-
Doesn't matter.
yeah, Feynman diagrams also have time associated with them.
That is a fair point. That is a really fair point. Okay. So in this case, this would be like I'm work best example. So electrons electron going left to right. Now,
Yeah, this is.
well, I
this
mean,
is-
left, right, time-wise, obviously. Forward. I'm not drunk enough for this.
This is a two-loop correction to the self-energy. Good luck with explaining this in an intuitive way. Like, give up. It's all I can say.
Okay, how about I don't start with the melon inception and just start with melon?
You want the easier ones?
I mean,
because
as much as this
this-
would be the easiest, right? The line.
Well, technically, the line is the easiest. Yes, that is the zero-loop correction. But basically, what we're doing is we have a propagator, but we cannot find the algebraic expression for this propagator. So for the line, so what we're doing is we're kind of doing a Taylor, like a massive Taylor expansion, where we just have different orders, and these different orders are guided by how many loops there are in the diagram. So
I think I get it,
we
but I feel like hold on, because you're doing the thing where basically you have to realize that you are an expert on the topic. I am very much not. So
no, that's fine.
Most of
That's
the
why you
things,
ask questions.
yeah, but like a lot of things that to you are obvious, I have no clue. So I want to start simple. A node in this case, what does it represent? Does it just represent? What does it represent actually?
Which one? Right or left?
Oh, that's not a good sign. Okay, let's go with the left one first.
Left?
Yeah.
It's just it's diagramic notation for a propagator, which is just a function describing how an electron moves.
Okay, and in this case, it branches into 4 pieces at each node. Then
That's the right hand side, yes.
Uh,
That like you start from the left, you go slightly to the right, you get to the first vertex. This is an interaction. So everything after this is virtual in the sense that it's not really measurable. It also in the sense of virtual bosons or photons and stuff.
I may fathom a guess that the line, the not full line, whatever it's called, I already forgot.
The dashed line?
Yeah, that's
Don't
gonna be virtual.
Nope. Dashed line is definitely insignificant.
Okay,
Like don't even look at it; it doesn't exist.
but then it's not a melon. Okay, it's fine.
If you want to know why there's a dashed line,
Yep.
it's because this kind of propagators with their coupling constants, they're a bit funky, and to compute the correlators and also the propagators, we need to do something with entropic something, and that you need to do a mathematical trick to find the right order and stuff. And that's why there's a dashed line. It's like these 2 vertices are your main 2 vertices, and everything else is like perturbation to that ish, as far as I
Okay.
understand. But I'm not too sure on that. So don't look at the dashed line.
All right.
It's not significant. It's
Okay.
nothing. It represents nothing.
Okay, I'm ignoring the dash line then. So we have the vertices. Then,
Vertices, yeah.
all right, I understand it as time doesn't matter which way it's going, the point is going. So this would be like the electron going. Then, once again, what happens at the vertice? That's the interaction.
Yes, that's.
Then,
If you stop at that time, it's like the exact moment when interaction happens. So when, for example, a photon splits from an electron,
okay,
that exact time.
well, let me draw my own melon for this. So,
Melons. Mm.
yeah, melons. Go, melon. Now, okay, so first, yellow line, that would be before the interaction. Orange, interaction begins. Red mid-interaction. Then purple, interaction ends. And,
No, huh?
no?
That okay, for the colors, yes.
Alright. Like, these are the points I want to understand. Yellow, orange, I think I get it. Beyond that, I don't.
Yellow and blue in this case are just a photon or a electron moving. So there is literally there's no forces or no interactions present. It's just this photon is just minding his own bullshit. He's just trying to move forward.
Okay, that
Nothing
makes sense.
happens.
That does make sense. Just line. Now,
Yeah.
what is red? That's my main interest right now.
Before going to red, let's first go to orange and purple. It's where an interaction starts and an interaction ends.
Okay.
So usually an interaction is something of the lines of electron emits a photon, but later absorbs that photon again. At least
Okay.
in case of loop diagrams, that's how it goes.
Okay, that
So-
makes sense.
So orange would be electron emits photon, and purple would be electron absorbs the same photon again that may or may not have undergone different type of interactions. So in the other loop diagrams, the higher dimensional ones, you had like this photon still underwent another interaction.
Wait, are these photons then?
No.
Ah,
But I'm
shit!
using
Would have
photon as an
been
example.
so easy if they were, because then it would make sense why there have to be two of them. Shit. All right.
But that's the third line. The other line is still present, so there's three. And that in that case, photons can't do that because you can't emit 3 photons from a single electron.
No, I mean the middle one would be electron, and the two other would be photons.
Yes, but then you can't emit 2 photons at the same point because energy
Shit.
conservation.
Shit.
I'm sorry to break it to you. But
I was so excited.
it's, I see the point, but no, they're all fermions. So basically, it can be 3 electrons. And this is the. But with 3 electrons, it's not very
You're
intuitive
making-
because we don't see them behave this way.
You're making the red line seem even more intriguing to me right now. What is the red?
Red line is just in the middle of the interaction, or at least between 2 point
Yeah, but
interactions.
why 3 lines? Because you said that every vortex has to be connected to 4 lines.
This is a very deep reason on how to draw Feynman diagrams. So you know what the Lagrangian is, right?
Lagrangian.
It basically it's kinetic plus potential.
Oh yeah, in that case, yes. Right. Yeah.
So kinetic part of the Lagrangian is the propagator, so it's just a line. The interaction points is the interacting part of the Lagrangian. And what usually happens, at least in quantum electrodynamics, is that you have, for example, a term where in the Lagrangian, where you couple a photon to an fermion, so say an electron. And in that case, you can have a vertex where you have one photon that emits, one electron that emits one photon. But you can also have for example, 2 fermions interacting with 2 photon terms. And in that case, you have a 4-point interaction where you have 2 fermions and 2 photons at that point. So the whole Lagrangian, the whole structure of the Lagrangian determines how your vertices look. I will give you an example in this case.
Okay.
Because I have the Lagrangian here. Or actually, I have the action, but same thing.
Do we want to, by the way, a whiteboard maybe?
Can, but I'm on my mouse, so it's a bit difficult to draw.
Don't worry,
especially
so am I. You'll be fine by comparison. That's the best I can offer.
Alright, where is the whiteboard? I send it in the meme, so open that and show on stream, please.
Okay.
Oh wait, I can also paste it in the whiteboard, maybe. Oh, we still have a whiteboard. New one. We're spoiling.
Whiz.
There we go. It's pink because it's a good day today. I can't copy it in.
Yeah, adding images to the whiteboard sucks.
So, the first term, the half psi I psi dot I.
Mm-hmm.
Oh, it's gone. Get it back. Yes. That is just kinetic energy. This is just how this just describes the propagators.
Okay.
Without interactions. So that's just a free line. In this case, free line. It's just a single line. That's described by the first term. The second term is interaction. And in this case, I would like to be q equals 4. Because this is a generalization, and we are working in q equals 4.
Okay.
This means that you have that your action is something dependent on phi1, phi2, phi3, and phi4. Yes, it's on the whiteboard now. Yes. So this means that any vertex that you want to have needs to have a contribution from psi1, psi2, psi3, and psi4.
So
which means that yes.
So every line will be just a different side in this case.
What do you mean? Wait, say ask the question again.
So every line will be a different sign in this case, a different propagator.
Yes. But we use the same notation because they're all fermions. So we, in this case, we can have this one be number 1, and then we need 3 others to interact, and we can just label them 2, 3, and 4. So that's how you construct diagrams. But now we're not done because this is an interaction, and we started with 1. We would like to end with the 1 propagator as well, so we have an interaction. So on the other side, we also have like the ending point.
Is it that we'd like to end with 1 because it's virtual?
No, because we don't like scattering.
Okay, never mind then. Carry on.
No, not scattering. We don't like decay. We want to start with as many products as we end with.
I don't get it.
Oh, my man just left. Okay, that's solid. I should have also left physics.
No, don't worry. Some people just aren't drunk enough. Don't let the haters get to you.
Good point. I need my whiskey. So, for whatever reason you want, we end on the same electron. It's usually electron in, electron out, and something happens in between. In this case, because this system is special, we need to end with the same and begin and end with the same label as well, because otherwise your normalization and Hermitian is fucked. But just start with this. That means we need to connect these somehow, and we could do that, for example, like this. Why would we do that? Because we can. So in that case, this would be number 3, this would be number 2, and this would be number 4. That's one way of doing it. But this is basically the same as drawing it like this in terms of the mathematics. Except for the part that you need to account on how many different types of diagrams you can make, and that's why you usually have like a normalization factor. So in this case, your normalization, I would have to do that from the top of my head. I don't want to.
I don't know if I am just biased because I don't know much, but this does feel like very similar to the Pauli exclusion principle thing, where there is. I know I'm forming in of a statement, but this is meant to be a question. Is it? Is it kind of like the Pauli exclusion principle thing where there's no way to know which one of these is which, but you could go that way?
No, the whole thing is that you just construct all of them. You want to know all of them. So you want to see all of the different ways of the interaction.
Okay.
So one Feynman diagram in like just this diagram. By the way, it doesn't matter if I write it round or straight. That like these are the same.
Yeah, it makes
these
sense.
two are the same thing. We want to know this single diagram also corresponds to, for example, expressions like this one, because they are different in terms of indices, but they are not different in terms of physics. The same thing happens, you just relabel. So to deal with that relabeling, you just put in the symmetry factor. And usually this is like 1/4 because you need, or 1/6 in this case, I think. Not, yeah, because you have 3 options for this one. Yes. So you just put 1/6 in front of that, and then you just normalize. So you can just look at this single diagram, and it will represent all these diagrams if you take into account that normalization factor. So that is for how you construct these diagrams. You just do it from the Lagrangian or the action. And in this case, we had 4 terms. And these 4 terms means that every vertex needs to have 4 interactions. But you could do something funny, but because this is still like first order, you could do, for example, let's have another vertex here where we have 4 interactions. Now things gets more difficult, because now you need to, for example, do like, yellow is a horrible choice. You need to do, for example, like this and this, and then this, and this, and this. But there's like way more ways of doing this, filling this in. So this is like a second order correction. And it also contributes less because it has more terms, which means there is more terms neglecting the contribution, because they all want to have the lowest energy, basically. So more terms just means less energy, less contribution. If any physicist hears this, they will be mad at me for saying it like this, but I think it makes more sense. And this is just equivalent to the one we saw.
Melon on the melon.
Yes. This one, I think. If I drew it correctly, I think so. No, it isn't. It's funnier.
Wait, wouldn't...
No, this is this one.
Yeah.
This is not a melon, and therefore it's just not contributing.
Could you give me an example?
No.
Okay, fair. I genuinely, like, normally when people start the sentence with could you, it's meant to be like as a polite thing, but this was a genuine question of if you could give me an example, because I knew that was optional. Like,
I started reading this like 2 days ago. I have no clue what I'm doing.
that's fair. Yeah.
Everything I just said up to you is just general Feynman diagrams. This part, I don't know where these fermions are coming from, why we want to consider only like the coupled, only like all of them coupling. Because you could also, like, for example, consider terms like psi I, psi j, in which case you could, wait, maybe I should also add up psi k, in which case you could just have an interaction with 3. This is the usual diagrams. This is usually like one of these is a photon, and then electron, electron, photon. Like, you're familiar with these, but
Yeah.
oh, you have at least seen them. And this just represents a psi I, and this would be an I, psi 2, and then an A for the photon, because it also has a polarization and stuff. Anyways, yeah, no, I have no clue what they're doing here.
But at least there is a melon.
Yeah, exactly. I like the melons and the melanification.
I'll be honest, I think, even more confused than at the very beginning, but to be fair, I mean, I get what the melons are. That's something.
Okay, I scrolled a bit. We have now a concept like rainbow diagrams.
You got my attention back. Alright.
I'll show this, and I think I'll end on this because I need to go back to studying.
Oh, it's fine. It's fine then.
No, you can still show it on the stream.
Rainbow diagram. Oh, I see. Okay.
You have to show it on stream for the people. Yeah. The rainbow diagram. Haha. I don't understand physicists, man.
And in the okay, the rainbow diagram will blow my head, because like I need to I'm still ignoring the not full lines. And
Yeah, in this case, you shouldn't ignore the dashed lines.
I figure,
You don't
because
know what they
otherwise
mean.
it's just a propagator.
No, they still mean the same thing. Disorder averaging, and the solid lines are fermions. So, but I don't know what this disordered averaging is. It's just a very different, like a very complex way of putting indices on your variables, something.
This vexes me. You do need to study on this, because I need to know. My feeling.
Now, wait, we're getting some fun stuff now. Wait, no, because now you can look.
Clearly have a pineapple slice diagram. All of them are fruity.
No, we're getting finally something
Oh,
on you, where you can actually have like more than one single fermion. So now you have also bosons.
Okay.
Of photons.
This computer, this line in the middle or at the bottom, just
Ignore
vexes
this
me.
line.
I'm having a lot of hard time ignoring the dash line, because this feels so close to being like familiar territory Feynman. Like, so close, annoyingly close.
Wait, I have something very fun for you. We also don't know what the dashed line is, as you can see by the picture that I sent right now.
Oh my goodness!
Just put in a question. He doesn't know himself either.
Oh, that's brilliant. Keep me updated, I need to know.
Oh, don't worry, I will. This is my Nobel Prize, remember?
That is, yeah, I do remember, don't worry. Whiskey's waiting. I
The
need to know.
25-year whiskey by now. Fuck you, Olo.
Yeah. It's gonna be soon. I believe my entire heart. Cookie Monster on heroin diagram. Looks like it looks bug-like to me. I don't know why. I have a very obsessive. I have a very obsessive personality, and I know damn well I'm not gonna do a deep dive into this. I need you to explain it, because I won't be able to answer on my own.
Wait, if you want to know what that reminds me of,
What does it remind you? It reminds me of a fly, like a fly looking at you, like POV, you are the whatever flies eat. Oh, but yes! Oh, that is actually, yeah. Yeah, no, yeah, that's, yeah.
it works so well. Especially the one with the eyes up, the yellow one. It's just that.
Like a massive...
I can't make anything out of it.
This is real physics.
Yeah, this is no equations anymore. No letters, no numbers, just pictures.
If not for the dash line, this is like so gettable. It makes some, like, I can see the fermion going in, the bosons and the fermions, and the fermions boson.
Next time I will erase all the dashed lines so you don't have to think about them. That's like so much effort. So I think you need to act up your imagination and just pretend they're not there.
I'll try, but question mark as well.
Oh, the question mark is just a physicist not understanding what is happening, and that's the mood. No, in all honesty, I think there's just an interaction there that we don't care about. So, like, question mark means it can be anything. We don't know. It doesn't matter. It's just a black box.
I mean,
that's what I think. But
that
I'm
makes sense.
I'll inform you when I'm there. It's like 20 pages ahead.
All right.
I will not be there anytime soon.
Okay.
Although it goes very quick when you have so huge melon diagrams. Alright, I'll let you work again.
Okay, alright. Well, thank you for the break. See you, Remco. Good luck.
Good luck to you as well. Ciao, ciao.
Well, that was a splendid break. Melonification. I think we've all learned a thing or two about melons. Oh, why does that girl look like an angry grasshopper? It's a melon! Well, not that one. That wasn't a melon. That included buttons. I can't even. Oh my goodness, we're back to this. Did the animation progress in any way at least? Hold on, I'll be right back. In the meantime, you all tell me if the animation progressed in any way, because I don't see the screen at the moment. Okay, and I'm back. I am in fact back. Make it, the animation did something. Oh, thank you, Adrian. Thank you, finally, something happened to me. There we go, metallic bond, everyone. Ain't that a beaut? 47 seconds per frame. Just use the image shows up. I was expecting it to show up. Don't worry. Was it supposed to disappear? Yeah, it does that sometimes. Don't worry about it. The point is, I'm gonna have a breakdown. We need to find something interesting, by the way, for the rest of the stream, because I will be editing a video, which is an extremely boring process, and so we need something interesting to do. Four-player chess. Oh, we haven't done four-player chess in such a long time. I don't know about Remco again. Remco's busy. And I will need Remco for four-player chess. How else to do? Minecraft Let's Play. No one needs it in the background. Plus, I get easily distracted. I still can't do it. No, I can't square the circle. No, Katsi goes fishing to rage bait Katsi because, you know, they aren't here. What happened to Katsi? What happened to Katsi? Where did Katsi go? Katsi left before even macaroni during the physics explanation. Is there a piano beside Make It? No. Why would you say that? I don't know why would you even say that. The sound is now an approximation of Planck's length. When Remco comes back, Remco's busy. I can ask him if you want. But you can just look it up. Well, Make It plays piano. Well, not right now. That would be silly. It makes no sense, but he did. Okay, we need to count this because this is ridiculous. But you come up with the theme. I thought it said music with my AI. Yeah, I did come up with the theme. Yeah. This is the Make It theme. This one. Like, a while back ago. I'm a composer and a pianist. Nobody I know is really musical in the slightest or is excited by musicians. I am sorry to disappoint, Miroslava, but I'm not that much of a musician. I'm really not. I can play instruments. I don't play them well. I have the ability to. Doesn't mean I can. That theme I've been stuck on for such a long time because I just cannot. You have to upload to Spotify and Apple Music. You'll never have any problems with finding creativity juice. No. Oh. Yeah, a bunch of great songs on Spotify. Just invent to. I can play your free after that joke. You should be. I should probably enable like desktop sound at this point. Might as well. I'll show you what I have to deal with.
First, the
Oh, that's too loud. Okay,
nucleus.
there we go. Much better.
First, the nucleus with seven. First, the nucleus with seven protons.
Is right here, and then we move the back.
First, the nucleus with
7 protons and 7 neutrons.
protons all have positive charge, so they push themselves apart. Protons all have positive charge, so they push themselves apart. Neutrons don't have a charge, so using a spillover strong interaction, the nuclear force, they keep the nucleus together.
There we go. Back in Southern Hell. You too? Do themes have their own names? Well, the Make It theme has one. This is the Make It theme.
Yes, positive charge attracts negative charges. And what has negative charges? Electron. Charge attracts negative charges.
And what has negative charges? Electrons.
Electrons. So it attracts 7 electrons. So it attracts 7 electrons to balance itself out. Then
Welcome back. We can make it if we try.
Just the two of us.
Have music also makes me lose my mind.
different shapes. So first we start with the two 1s orbitals. Then
Yeah, I didn't get it.
those 1s orbitals. Then two 2s orbitals.
Orbitals?
Then three 2p orbitals. And there, behold, a nitrogen.
I said orbitals in the... Ah, damn it, I said orbitals in the video. But obviously, you should have been electrons. There's one 1s orbital, one 2s orbital, and 2 electrons on both. Damn it. Is nitrogen used in nitro? You know, the stuff that makes cars go extra vroom vroom. Thank you for the very scientific description. I was confused, but I don't know, not a chemist. I thought there was more than one.
It's the thing farmers take from bomb manufacturers.
Is there more than one? There is actually a couple of Make It themes. There is the theme 0, the theme 1, the theme 2, the theme 2 short, the theme 3, and the theme 4. I am very creative when it comes to naming things. Indeed.
Nitrogen and bring them both together, the
What do you consider as science?
nitrogen. Now as we take another nitrogen,
What do you mean?
Adrian asked no any science question, I will be answer them. What do you consider science?
Are most scientists creative? I would say very much so. Have you seen the melon diagrams? I would say we have proof that scientists are in fact creative. Most scientists are just high as fuck. I wish. I've been saying it for such a long time. Government subsidized drugs for scientists. It would speed up scientific development by decades.
To be honest.
Oh my goodness, I am so high on... I mean, I'm grounding on sugar high right now because I've overdone it in my tea. I completely misjudge how much sugar needs tea. How much tea needs sugar.
What?
Yeah, no, it just means that in like... Funny enough, at the beginning of Shiba, I did thought I was having a stroke. Apparently it was just someone... Yeah, someone was just burning something outside, so I just thought I had a stroke.
I don't think you're smelling burning toast when you have a smoke. What? A stroke. I don't think you smell that. I think that's a false information.
I'm smelling a stroke, I must be burning. Is it okay to learn basic single integration and double integration the same day and still be able to act normal? Integration isn't quite as rough. I do believe it's one of those like great things that are have a reputation for being scary, when in reality they're fine. Free drugs for scientists and makers. I mean, I'm just saying, if science gets some, why not science communicators could also help.
Now, as we take another nitrogen and bring them both together, the
As long as they
electrons
don't get
change.
hooked.
And now they look like this.
Oh, I can quit whenever I want.
And the electrons change. And now
Oh, that's wrong. This. They say love hits you hard, well, love hit me like a train.
we have
Love
two
injured
electrons
my brain.
S.
I'm concussed, but I must love
We
my
have two
brain
electrons on
trauma.
S.
Hmm.
Don't wanna hold on to the brain trauma. Shape of this bruise is all that I've left of you. So in some dumb chess game thing in Python, I got bored. Been there. I just have more googly eyes I can put up stuff. Whenever I look to the side and just see... Oh, never mind, my camera died. Well, I won't show you. The point is the knife of googly eyes. It still makes me laugh. It makes me smile. It's great. Indeed.
Bees trigger.
Can we extend to the other make it themes in the background? As I was going to ignore it, in which case it would be very good. The stuff that makes your head go... The make it themes. There ain't much to listen to. The theme 0 is just my original... this is the first one I made. Just because I couldn't get that melody out of my head, so I just... That's it. That's the entire thing. I just had to get it out of my head, so I did. The theme 1 is just an extended version. Theme 2 is Soda's version. The theme 3 is what Tefta made when Tefta made the remix, and theme 4 is when Tefta remixed it but this time by AI. But this almost like a drag. It really does stick in your head, doesn't it? I cannot get it out of my head no matter how hard I try. I need help. What key is it in? Let me check. It looks to be... So it's a D, B flat, G, E flat, has a E flat and a B flat, so not A minor. It's going to be. Is it G minor? It might be G minor. No, it's not. G flat. No, it's not G flat. First chord. Well, the first chord is G minor chord. G, B flat, D. No, it doesn't feel right. That don't feel right at all. It should go like this, should go like this. It could be B minor actually. No. That's major make it. What the You know what? I'm done. I'm done. Enough distraction. I'm losing my mind.
That's not what it says, make it.
Peasant.
We have 2 electrons on the one S. We have 2 electrons on the one sigma. We have 2 electrons on the one sigma orbital. We have 2 electrons on the one sigma orbital. 2 on the one antibonding sigma.
Bunch of open listening here, so I'm just gonna bring a huge chunk of animations.
2 on the 2 bonding sigma. 2 on the 2 antibonding sigma. And then 2 on the sigma bonding from the p orbitals. And finally 4 on the 2 pi bonds, and there we've run out.
Sorry, I'm thinking I'm going to transcribe that. That's cool. I can just give you the notes if you want. It's not many. It's 4 chords. Not a lot. Semi-autonomous peasant. Someone called me once a semi-autonomous peasant. It was quite. I felt insulted. Quite rude.
There.
G minor, E minor, C minor, D. Yes.
We've run out of electrons.
Got it spot on.
So this is what those orbitals are. These shapes. So why did I show you them from the perspective of energy? Well, it's because if I take the differences in energy between nitrogens on their own and in a bond, then this is what we get. We have to remember to duplicate the nitrogens on their own because that's 2 of them. And then if I just put all of these cylinders together, we get more energies from more
Energies from nitrogens on their own, then the bond.
more energy from nitrogens on their own rather than in the bond, which
And I think this animation is wrong if I'm not mistaken.
means that if you want to break the bond, you need to make up the difference in energy. So this is the energy you need to put in order to break the bond. Or in other words, this is how much energy nitrogen emits when it goes from atoms to a molecule. Or conversely, how much energy you need to give it to break the bond between nitrogen atoms and break the bond between, or conversely, how much energy you need to give it to break the bond break the bond between nitrogen to break the bond you need to give it to break the bond between nitrogen.
Almost perfect. Come on. Give me. There we go.
Energy you need to give it to break the bond between nitrogen atoms in nitrogen gas. And so there we go. This is what the bonds look like. This is why they happen. This is why molecules don't randomly break down. And oh my my goodness, we just started the video. And oh my goodness, we just started the video.
Because right here we're gonna have the next chapter, and we just keep going forever, ad infinitum. Okay. So right here we have 24 minutes so far. It's good. It's good. We're making good time. We're making good progress. Is in fact G minor. Oh, so I did get it right. That's good to know.
What's up? Just, whatever, mute this, it's fine. Okay, that's because our
This, and there we go.
okay, that's because our
Have you already had 24 minutes? No, I haven't. So far we've only done 8, and it's not even edited. I'm just placing the animations. After I place the animations, I need to like bridge the gaps in between them, because if I run through the video you will see that most of it's black screen, because that's the space in between the animations. I need to bridge them. I need to add all the sounds, all the music, all the edits and everything, and then the video will be finally finished and over. I'll be forever. And by forever I mean like, I don't know, a couple hours before I start working on the next video.
electrons are a bond to change.
It'll be 5 minutes, exactly.
A topic I've briefly touched upon in that's because our orbitals don't need to go into a bond to change. They can okay, that's because our orbitals don't need to go into a bond to change. They can also hybridize. A topic I've briefly touched upon in the last video, but this time to give you a more concrete video. But this time to give you a more concrete understanding of it, imagine a carbon atom. In this carbon atom on the valence shell, which just means the outermost shell, we have 2 electrons on the 2s and 2 electrons on the 2p. Now you might be wondering, which of the 2 orientations of the electrons are
This right here. Here. Yeah, we just need to keep going with these because this is a loop.
2 orientations of the electrons are. Now you might be wondering, which of the 2 orientations
There we go.
which of the 2 orientations the electrons are.
About to make me sad, but I'm working, Adrian. I'm working.
Well, they are on all of them, but only on the 2, if that makes sense, which it shouldn't because it doesn't make sense. So
Yeah, this to the right.
basically, let's just say that the universe doesn't exactly know where they are until we do something with them. So with that in mind,
Never mind this one. I'm listening to. Oh, I forgot to unplug the Raspberry Pi, by the way. I just remembered. Yeah, I should probably unplug it just for the sake of like, if it runs too long, something could happen to it. No, I don't want that. Ah. Okay. You know what? I think I'm gonna end the stream for now, because this will be extremely boring to watch. So I'm gonna go. I'm gonna probably have a short break to eat something, and then I'll be back to it. Hopefully, by the end of today, the video should be out. Worst case scenario, it should be by the end of tomorrow, unless something happens to me. In which case, just assume I'm dead. For now, that'll be it. Thank you very much for watching, and have a great day. Bye.